Right. Okay. I'm gonna start the stream early, by like 2 minutes. Mostly because like I'm annoyed. I went to do the data and I had to go fucking fix their script because I guess I've got something wrong set up in my Python. Maybe I don't know. I literally just downloaded Python to get it to generate the values, and it decided that it wasn't gonna work because they hadn't specified UTF encoding, and my computer just said no. There's non-ASCII characters in there in like the list of weather stations. It's like the fancy like if I do this, like over U1010 backslash 1010. I don't know how to do it ASCII. UTF-8. We'll just copy it from the fucking when I searched it. It said this character. Yep. Like this character doesn't exist, so it couldn't read the file. I fixed it for reading, and then it couldn't write the file, and it turns out like a fucking 3,500 times in this fucking document. So like, kind of important. Anyway, it's also generating the data in the wrong place, but that's mostly because I was just gonna get just what I needed, but I couldn't fucking get the script to work. So I was like, oh, I'll just clone the repo, then it'll work. And then no. So I'm just annoyed. So I started the stream like 2 minutes early to rant about that while I wait for the data to download. I also think I have to wait for the entire thing to download before I can actually transfer it across. Anyway, we'll put it in the assets folder. I was going to do it in Bevy, but Bevy spawning 1,000 entities uses up every single bit of memory on my computer, or 64 gigabytes of it. So no, we'll just do it in pure Rust, and maybe later, like we'll see about doing it in Bevy. I don't know, because I can just like tell it to only do 1,000,000 or something, which would also work, but not nearly as impressive as 1,000,000,000, so we're going to do 1,000,000,000 first. Get everything set up. Okay, so we're going to go fn main. I don't know why my ID doesn't like having an empty file, but anyway. Do that, and we're going to, I guess, I actually don't have any idea how we're going to say it. I guess it's going to time everything and see how long it takes to get to do the 1,000,000,000 files, and then we'll do some optimizations, and my hope is to get it like less than a second, I guess. I don't know. I actually have no idea like how well this is going to go, because I have not like attempted this at all, and all I've seen is in things like in Java and that with like dedicated stuff, people have got it under a second. So hopefully with Rust we can get it under a second without too much effort, but who knows, because it does rely on my ability to actually know what you can do in Rust, which, you know. So let's just go with first. I want to do it like split up, just because I feel like that'll be more fun to optimize. We have to wait for the file to be done. So we're gonna say like first file, and we're gonna say something like maybe, again, just for the fun of like doing it properly, we're gonna like p where p is as ref pa. I think that's how you do it. And we say file. We're just going to take in, I'll just take in p, right? And then we're going to go, we're going to return, I guess, a hash map. And it's going to be a hash map of like string, just because it's like, it is really obvious to not store too much data, just to be all like, struct, be like, measurement. Okay, it's a measurement, and we're going to say min, which is going to be, I'm going to use a U32 because, you know, faster. Max U32, and average, which total, and count. Right, because that's a way of being able to calculate the average at the end without needing to like stack everything. And basically we're going to store everything at 10 times the value, so we can store it as int without the float, because it says everything's to one decimal place. And then at the end we can just shift it, like divide by 10, and that's our value. Like, anyway, so we're going to, for now we're just going to go string measurement. Like that. And this file's job is going to be to return our results. To be honest, because it was going to use Bevy, not anymore. File, We should probably also just say opt level 3 because not a right. Profile dev is opt level 3, something like that. No? Oh, it's not quote 3, it's number 3. Okay. Yeah. So we're gonna use index. No. Index map. That was called index map, I think that's called. So index map is just like a hash map, but it like stores the order of the values we put in. So that will allow us to index map. Wait for it to finish compiling everything. Yeah, we probably should not have Bevy included because it's just going to slow down the compilation of everything. Cargo in. The Rust analyzer is going to continuously try to parse Bevy, and it's not a good idea because we're not actually using Bevy. Anyway, we're going to index map. We'll just bring in. We'll qualify this part. And then we'll just like to do. So yeah, the index map will mean that when we insert them, it keeps the order of insertion, which for this doesn't actually matter because we're just going to stick them in whatever order we come across them first. But it means at the end, when we have to print them out in order, we can just like sort the map, and it'll actually like then reiterate through the map. It'll be in order. So yeah, it's not that hard. So what I'm thinking, maybe instead of doing this, actually, we're going to say parse file. Instead of passing in an actual path, we're going to pass in a file, which is going to be a std.fs file, like that. So we can actually just like read the file. So we can say like that file equal std.fs file. I think it's open options actually. Open options. New dot open. We're just going to paste in the path, and there's going to be like /asset/ I think it's measurements.txt that it's making. I actually have no idea. Okay, so it's all just happening off on the other screen as I it is done. It took 7 minutes. Okay. So we're just going to copy this across into assets. It's going to take a while because it's like it said 14, it's 16 gigabytes. Anyway, so just going to rename this quickly and grab this measurements.txt. Say, please open, oh, no, please open measurements.txt. And we'll just unwrap it and see if it plays it. If it fails on the first line, you know, we can just restart it. It's everywhere else we want to do error handling because we don't want to like have it fail and then not make it to the end. Then we just say measurements, like parse measurements, and then we're going to say measurements.sort. I think, can we just sort? I don't know. K0, like this. I don't remember how the sorting works. K0, K1, something like that, I think. Can't do it midway. Okay, so mute measurements. Sort by, so we have K0, K1. No, why are you not like that? Because you want a function that takes in key value, key value, key value. Okay. So it's not K0, K1. It's like K0 underscore K1 underscore? Is that how you want this function? Yep. Okay, cool. I mean, technically, I think the file could be done differently. Yeah. So I also feel like I don't want to do it as a string. I want to do it like as a sequence of numbers. There's something like 40,000 things. I'll bring that over as well. This is the list of weather stations because I think it's randomized about which weather stations it picks, but I don't know if it would be cheating to go in and like do pre-processing on this list to work out like what is the minimum number of characters that I would need to take to have a unique key, because if I can just work that out, then I don't actually need to store strings. I can just store the names as like a integer and then hash that instead. So that was one of my plans that I was thinking about when I first like did this. But we're going to start with strings because again, we're just okay. So I actually don't know how you know if you solved it. Like there's not. Where is my billion lines challenge? What tab did I have it open on? Who fucking knows? Yeah. Okay. Does it tell me like? Does it generate like an answers cheat? Like How do I know that I did it successfully? Results, no, so I think it has to be under the results. I don't like that they put the results above the instructions on how to actually generate the data. It's such a fucking annoying thing. They have to scroll through like so much shit. Okay, build the project, which I don't care because I'm not doing it just once. Take a few minutes, it generates it, yeah. And it says, yeah, okay, okay, calculate average baseline to SH. This provides a naive example using Java Streams API. Processing the file completes the task in 2 minutes on a result evaluation. It serves as the baseline comparing your implementation. Okay, so it does have a results evaluation, but like the issue is that I'm pretty sure I need Java on my machine, which I probably have because I've run Minecraft. So, but like it's just like you have to run like an external program that just spends 2 minutes actually doing it. Like I'm sure I can just assume that my answers are correct. I mean that might not be cheating, but yeah, I'm just going to assume that whatever I get is correct. And then we're going to print to a results. So we're going to say like that commute file equals std fs open options new dot create can be true dot truncate can be true dot write true dot open, and this is going to be dot slash asset slash result dot txt. Right. And I think when we time it, we're only going to time this bit here and these two, because that's the actual bit that takes time. Maybe we'll time from opening the file, but once we get to here, we're going to stop timing it because I want it to look nice, so I'm going to print it out nicely. I don't think that should count towards my time of like spending extra time to format like and write to the file like in a lazy way. So we're going to say station measurement average is total as F32 divided by count as F32. Only one decimal place, please. Line format. So that's not how you do that. You say use yeah, std, is it fs file system, right? Yeah, right. And then we go something like write, and we say mute file, and then we go and do this. I don't even know if this is the right format that it wants the output in, but again, I don't actually care because I would rather it look nice. I like look in a way that I actually want to read it rather than oh, we didn't like unwrap that either. I don't know if having a random file open, we can time that too. So I'm going to open this file before we start the time. So this is now, just so that I don't have to worry about like if it crashes after doing like a 10-minute run. Can't write the trait in scope. Oh, so it must be use std. Is IO right to write to a file? It is, and I'm just gonna like let underscore equals. We then unwrap it, which is kind of fun. All right. Using write for format string that ends in a string. I like that it catches that. It's kind of cool. Yeah. We don't care about this line. Okay, so we calculate the average, which we should almost certainly do outside of the loop. So maybe we'll just keep an extra. We're gonna say average. Which is an F32. Anyway, we're just gonna like. I guess we do the measurement, and we're gonna say measurement like for each. I want to say it's for each, but it must be in a mute dot for each. Does it give me the key as well? It does. So we need to go like underscore v, and then we can say v dot average equals v dot total as f32 divided by v dot count f32. Right, cool. So we do that because then we don't have to calculate the average here, and it means we don't like not time the average. Then it's like measurement dot average. It does mean we're going to store a little bit extra data, but I don't think that should matter. We can parse the file, measurements, parse file. Okay, so we're going to start the timer here. So let's start equals std time instant now. All right, and then we're going to go, when we get to here, we're going to say print line 1 billion passed in elapsed, right? Then we're going to start a new one. Let's say let's I guess log equals sp time brain time instant now, right? And then we just, when we get to the end, we're gonna just like record how long that took as well, simply because I would like to know if that's a big factor is actually writing the answers out to the console. But technically I'm writing them a file because to the console would like bloat the console to help, and I'd rather be able to look at a file at the end rather than just try and scroll through the console. Yeah, so what we're going to do is we're just going to return an index map. No, and then we're just going to run this immediately and make sure that you know, this works. So we parse in the file. We say parse in file. So you don't need to just redo. And we start. So let's just run this. This is going to run in debug mode. We don't want that. It didn't work at all anyway. So I'm going to say run dash release. Okay. Why is it not working? So something about must specify at least one of read write. Okay. Read. I know before open. So dot read. True. Okay. So it took 100 microseconds to just generate the thing and return, and then 100 nanoseconds to write the file. So writing the file is actually really, really slow. But I think it's because it created the file. Like I feel like if we run that again, it's not going to. Yeah, it took 0 nanoseconds. And I suspect that's because the operating system didn't have to do anything. So there's no syscall. All right, cool. So I guess we just start processing it. So we're going to go like mute measurements equals. We could initialize this with a bunch of values, but that's an optimization for later. Because again, if we're going with like the faster, is that a thing? Buffer reader. The buffer reader struct adds buffers to any reader. Yeah, it can to work directly read instance. Okay. I don't know if you already had a file buffer. Anyways, that'll be fun. So I guess it's what the fuck is flatten do? We're just gonna go like again, lazy approach first because it would be interesting just to see how fast Rust is. Wait, why are we going so for line and then we have to return measurements? Okay. So why don't you like lines? We could read to a string, but that again just seems really slow. Okay. Can I just ditto? So we can call buffer and call capacity. The issue is that it's a UTF-8, which means we can't just read to end, read to string. Alright, fuck it. Okay, so we can do this in optimization later. So we're gonna say let string let root string. Because again, this is gonna be like a terrible implementation just because I want to know like the baseline. So string, new string. No, stop turning it into a reader. File dot read to string. And then we pass in string. Like so. It needs to be middle. Like that. Cool. I think you also need to be middle. I don't actually know. Read to string. Yep, mute stuff. Okay. So we say read. Then we say it's like string dot line. Like that. Right. So then that should like give us all the information we need. We don't care about the result. Let's go. Okay. Cool. So that should then let us be able to parse each line. So from what I remember, so this file's too big. Yeah. The way the file's laid out is like this, but it's only like a single decimal point. So it's like that. I think. I legitimately can't tell because the page is written really weirdly. Like, I think it's again because it's written for Java specifically, but like the Git repo that explains everything is like, oh yeah, square bracket time, like like name square brackets, angle bracket. And it's like, is that how they're laid out? So like it says angle brackets string station name colon double measurement, and it's like this is what it actually looks like. So I think it's because it's like a Java thing where they're declaring like the type inside. Apparently it's supposed to look like this, but again, I don't actually care. Yeah. So basically it boils down to name colon. So that's pretty easy to do because we can just be like that station station equals it's like station comma measurement. Right, like this equals line dot split once. So sum line measurement like this. We need another set of parentheses like this. Okay, and then this is the semicolon, and then else continue. We're just gonna print line invalid line. Okay, we'll do that, and then we're gonna go. I think we'll parse the measurement ourselves simply because it'll be pretty easy. Yeah, maybe. Yeah, again, like we're going for like unoptimized just for the sake of like making it like a comparison. We want to see how much faster I can make it by doing my optimizations. So trim parse into, no, we want it to be an F32 that we're parsing it into, and then we want to return. I guess we want to. Okay, so first things first, we have our measurement. So we're going to say let entry equal measurements dot measurements dot I think it's dot entry like this, and then we say like station, and then it's like or insert or default. Yeah, or default. So the idea being that when you call entry to string, it will use this key to look up the value, like keeps the key so that if the value doesn't exist, I'll use default for this, which is just to be derive. Actually, we need to implement default because there's some tricks that I want to do to make this like nicer. We're gonna implement default measurement. So yeah, min is max and max is min, which just means that as we oh, does it have negative numbers? It might. Alright, interesting. It does. Okay, so these need to be I. Okay. So which also means you need to be I. Right. So the I'll make you an I just so we don't have to compare later. The idea is that you want your min to start at max and your max to start at min. Otherwise, when you try and set the max, it'll just like be 0 if you ever get a negative number. Like the min will never go, like the max will never go below 0 even if it starts at -0. So you start at like negative infinity so that it goes up to 0. So we're going to say measurement trim purse. Your type is a F2. Actually, I'm gonna match you. I'm gonna take you as the F32. Okay. So now we have our entry, and we're gonna say, hey, we have an entry. We're gonna go here, and we're gonna go here. We're just gonna say like V as I32 is V times 10 as I32. So the times we like 10 will be because we always have exactly one decimal place, which this doesn't actually do. Yeah, we'll only ever have one decimal place, which means multiplying by 10 will make it a whole number. And then we just go here and we just say entry dot total plus equals this, entry count plus equals 1. If entry, just entry dot min equals entry min, and entry max, the max of the max and the min of the min. And then for some reason you don't like type annotation needed. Why would you need a type annotation? You know the type. It knows the type. I don't know why it's confused. Okay. Anyway, so basically invalid measurement. Cool. So we work out what it is as an integer. We then add that to our total, add that to our count. We might want this to be an I64 because I think the total is probably going to go pretty high. Billion times 100. Yeah, likely to go above 4 billion. Alright, so we're going to say total is an I64. And that means we could probably make you an I64 as well, just to keep track. The min, the max shouldn't ever. Maybe we could go down to like I16. I don't know. I don't know how the padding works and that kind of thing. And then we'll just convert it here as an I64. Just because, like, then we don't have to worry about these ones. Alright. Yeah, we could do like an IA or I16, I guess, because it's never, I doubt the weather stations are ever going to return greater than 100 and never like greater than negative 100. So I6, an I8 would even work, but anyway, gotta keep going. So I think that should just work. If memory, if my reasoning is correct, maybe we should have some kind of way of knowing it was still alive. Who goddamn knows how long this is going to take? Oh, this is terrifying. I don't like my CPU speeding up. It's also like doing nothing in parallel. It's using a lot of memory. It must have loaded the entire 16 gigs. Okay. Good job. It's gonna be like one core capped out. No, it's not even. Ooh, peak. It's also swapping which core it's on, which is kind of fun. Interesting. It did pinch a lot of like hard drive for some reason. Yeah. The question is, how long is it actually going to take? I probably should have like had some kind of thing that was like every 1,000 lines. Please just like tell me. Maybe we should just implement that. Like let I equal 0, I guess. Maybe we should just do the enumerate because this seems like it might be better, like just simply because the compiler might do something with the fact that it enumerates like a built-in thing from the Rust team. Anyway, so we do this, we do this, and this. When we get to here, we're gonna say if I is multiple of 1 million. That's 10 million. 1 million. Can we? This is gonna admittedly slow everything down. Oh, there you go. So it took approximately 2 minutes. We don't need this. 2 minutes is fine. I can pretend like it's working for 2 minutes. Alright. I want to know how to do this fancy, like fire maps and stuff like that. It's kind of cool. Anyway, so 1 billion records processed in. Okay, so maybe we should get it to actually print this. Yeah, okay. So how do we do that? So kind of want to actually we can leave it on. Yeah, cool. So if we say like out is result.txt, So we're going to say like records processed in the semicolon, but this is not going to be a new line. And then we're going to say you like backslash tab, and then semicolon. But you actually print a new line, but you're not going to write. You're going to say write out, right, like that, and then right line like that, right? So that should then record these into our actual file. So results. Okay, not what I was expecting. Negative 999,999. Average of negative 0.1. Interesting. Okay, not at all correct, but thank you for trying. Right. We should also put that in a different thing. So that's out. So we're gonna be like let new. Results. No, it's gonna equal. Yeah, log. There we go. Okay, so it's log. Cool. And then you're gonna be results. And you're also gonna be results. Right. Except results needs to be create truncate false. Write true. Append, I think, is the other one. So append like that. Okay. All right. Append sets. Right. Okay. Cool. So of course, because I think write means start from the beginning, whereas append means continue from where the file ends. Right. So we're gonna say new file. Log.txt. All right. I'm gonna just paste in records processed in. It was 11.5. We'll call it 5.3. I'm going to say 2 decimal points and then space and then results. It's also just like wrong. So I'm going to say it's like tab results written in. It's I don't think results written in is going to be that important because again it's not going to actually take that long. But it says 110.93 milliseconds. Right. So we need to change those to format. 0.2. Same with you. 0.2. Lovely. I don't know why it's doing that here. So yeah, milliseconds, seconds. What was the other thing we need to change? Oh, yeah, it's just like not getting the right answer. Why is it not getting the right answer? When I printed it out, do you print it out like with some kind of restriction? No, min, max, and average. So it's like actually just getting. No. Also, why are you not printing per line? Because you're not right line. Right, so then they would all be on new lines. So we're also going to put at the end of here. Okay, so it failed because it didn't actually do the right thing. But why is it negative 99? Like, that's my big confusion, is it's getting 3-digit numbers. Negative 999. Max is 999. But why? It's also getting different averages, which is even more confusing, because, like, that implies that it is actually... Do I just, like, not set it correctly? So we say measurement.min, and measurement.max, and measurement.average. And to calculate the average, I think we do the average... the average is just before, so its average is total divided by count. So average is actually working for some reason. So entry min. So the min is the max, and the max is the min. I legitimately don't understand how it gets to that. So I guess we'll just print some stuff out. Kind of panic here and debug. Right, so we're going to say maybe debug entry. Because I just actually care what the entry is. Can't, yeah, because entry doesn't have debug. Okay, cool. Like that, cool. I am going to just run this. It should just like crash immediately because it should. Oh, apparently a large chunk of that time is loading to a file. Oh no, we still iterate through the whole thing. No, we want to panic after the first line. No, close. We want to panic here because I want it to just do one line. Otherwise, it take 11 minutes or something. It still does take a very long time to load that file into memory. I gotta go. That's because it's reading the entire file. Yeah. So why? Because we didn't shift it back. Okay, interesting. So the minimum temperature was negative 275. The maximum temperature was negative 275 because we only did one line, and the total was negative 275. Now, question: is our very first measurement? Oh, we have to actually like open anyway. Ooh, is it? Oh no, VS Code is not gonna allow that. It really doesn't. I can see all my fans kicking on and just trying to open a 15 gigabyte file. So that's fun. Hello, welcome to the stream. So what is going on? So that does tell me that like the results are actually the results that it printed, except it cleared the results this time, are that every station got to negative 99 and every station got to positive 99, which I don't believe for a second. Why was it doing that? Or default. Oh, okay. So that crashed code. So the answer is I can't even check that the negative first number is negative. Okay. So fun thing about that. Interesting. So you do that, and then you add one, and you do this, and then in the max, the min. All right, and then we're gonna debug the entry. So we're gonna say, I guess, let mute I equals 0, and we're gonna say I plus 1 plus equals 1 if I is greater than 10. Just gonna panic. Just to get it to stop up to 10 runs this time, just so I can see a little bit more data. The issue I'm seeing here is like, I can't see why it's getting to 99 and getting stuck. And the annoying thing is I can't go in here and look at the data to know like, is there just a bunch of fucking 99s? So there's negative 66, which seems wrong, because why would there be negative 66? That seems way too cold. All right, so what we're gonna also do is we're gonna print out the line as well, I guess. When we get to here, we're gonna debug station and not measurement, and measurement. Okay, run that. So then it will tell us a little bit more like of what's going on. But like negative 66 seems way too high, so I don't understand where it's getting it from. What was the actual measurement? Okay, never mind. It actually was negative 66.6. Measurement was negative 25.4 or 32. So what that's telling me is I think maybe there's a bug in the generation code, and that like every single thing actually legitimately does go from. Okay, so we can prove it out. So we're gonna do is we're gonna do this, we're gonna do this, we're gonna say if the underscore equals 999 or negative 999. Okay, we don't care about this. You can go away now. I'm just going to do it like a full run, which again is going to be really slow, but I want it to print out suspicious measurement. I don't care about the line. Suspicious measurement for station. Because it's like the implication is that like basically every station has at least one. I guess it is a billion records, and if they're just randomly picking numbers, the odds are that like one of those numbers will be 99. See, like that seems like a bug in their code. Why would the answer is just always every single fucking station has negative and positive 99? Every station. Interesting. Okay, so first of all, let's stop it doing that because it's going to make it take a really, really long time. So we're just going to say, like, don't even bother doing this. Do this. I'm going to go run. And you're going to tell me what the min... So this is going to be like an actual proper run, and it's going to record its measurements. And, it's so stupid. I mean, it kind of makes sense because there's a billion records and there's only like, if they used every single station, we'll find out when it prints it out because it's going to print one station per line. But if they used every single station here, they've got 44.69, so can you get a calculator up? So I'm going to say like 1 billion. Wait, that's 1 trillion. Did I make 1 trillion lines? I have no way of opening that file. I have to go to this and go, did I type 1 billion? 1,000 million. No, yeah, there's billion. Okay. There's 1 billion. We're going to say divide by 44693. So there's 2,200 entries, and there's only 10,000 possible ranges. So the fact that every single one of them goes up to 99 and down to 99 is not actually unreasonable in like statistics, in terms of like there's at least 2 copies of every possible number, I think. Right? Because there's a 100 times 100 is 10,000. 100 times 100. No. So there's 99. So there's 1,000 times 1,000. This is like a million possible numbers, right? Because there's 100 times 10 possible values times 2 because it's positive and negative 2,000. Yeah, no, never mind. There's 2,000 possible numbers it could pick. Now I feel like I need to go through their fucking create measurement code and go, how the hell are they picking these numbers? Do they intentionally avoid coldest temperature, hottest temperature? Weather station, K equals 10,000. So it's 10,000 stations. Batch size 10,000. I have a feeling that no matter what, you'll always just get lots. That or the way, because they're doing chunks of 10,000, is that they may be generating like 1 measurement per station, and what's happening is that every station is just getting a maximum measurement. But like, I think every single station I think is hit positive and negative. No, so I didn't sort properly. Well, maybe they did, because yeah, Z, and then these are considered to be after the alphabetical. I don't know how that works alphabetically, but yeah, the average is like 1.23. Here's the issue. I kind of need to. I don't think my code's wrong. I think the fucking generation is just flawed, that it just ends up with every single station because a billion is just too big of a number. This is what, as I said, there's 2,000 possible ranges because there's negative 999 to positive 999. So there's only 2,000 possible values. You can pick not even. It's 1,999. And there's 20,000 entries per station because there's 10,000 stations, isn't there? Yeah, 10,000 stations. Not even 10,000 stations. Okay, that makes even less sense because didn't say I was picking 10,000 stations. Shouldn't there be exactly 10,000 stations then? That's also concerning. Anyway, the key point being that there's if there's 10,000 stations and a billion entries, that implies like 10,000 entries per station with only 2,000 possible guesses. That's like a 5 of every single possible temperature, and it doesn't seem like they did any kind of normal distribution. It was just like they just picked a number randomly, so they're all averaging basically. I don't know, it just doesn't make any sense. Where's the fucking, like, the thing? Is there like a example result? What the fuck? Calculate. Yeah, I don't care. No licensing. Like, what the hell does it? Like, all the values are just 99. Did I fuck up somehow? I don't know. Results milliseconds. Yeah, but like, I want to know what their result was because it's stupid. Because the answer, you didn't even need to calculate the minimum and the maximum. You can literally just say that it was 99 because statistically speaking, it's not going to be anything else. I don't get it. Tester SH. No, it runs through the tests. Okay, yeah, this doesn't make any sense to me. Like, surely just every number is 99. Like, 99.9. Which makes me think maybe my code fucked up and generated the wrong thing. Maybe we'll get it to regenerate. So, it says... How do I do that? I'm gonna go to here. Script main Python. Okay, I'm gonna open a terminal here. I'm just gonna say dot slash no dot slash defeat it, pipe it to Python. No, fuck's sake. Python dot slash 123 123 123 like that. Okay. So I'm just gonna get it to regenerate me another one. And we'll paste that in and see if that also gets 99. Like maybe I just got unlucky and I managed to hit, like maybe except it does do batches of 10,000. Then maybe one of those batches happened to hit 99 and it just fucked everything because it meant that like every single city got way too much. Yeah. How long did that one take? Wait, did this one even finish? Oh, it probably did. Yeah. So one of these is not printing a new line, which is kind of dumb. Is it you? You should be writing a new line. Why did you not write a new line? It also only took 95 seconds that time. This was supposed to be 100. I don't know why it was faster that time. Yeah. Question mark? It also took 10 milliseconds longer to write it out to disk, because it's probably because of the new lines. Which is interesting. Anyway, it cleared the results, which is kind of funny. Yeah. What are we doing? We're speeding things up. Okay. So, well, I guess we'll go to Git and we'll commit this. This is not well. We want to go add existing repository. We want to change. We want to go to YouTube, projects, OBL. Add this repository. All right. So this is going to be like try one. Okay. Oh wait. So the don't commit. Have to go to the git ignore and say don't commit assets. Oh, don't commit in the git ignore. Don't do slash asset slash measurement dot csv and weather stations. Or results. Don't paste results either. There's a lot of things not to put in. Maybe we just move log out here. Well, actually, we have to leave log there, otherwise it'll fucking do it again. We'll leave log there for now. Oh, and it's already finished. Okay. That one took 100. Okay, so that took the same amount of time. Yeah. We're gonna move the log out here. So we're just gonna go back to our code and we're just gonna dot ignore assets, just so that we don't accidentally include those. But I want the log because that's like how we actually did. So again, it's all just fucked results. Then we go back to main and we just say, hey, when we log our results, they just go in dot log. Thank you. So how's this going? We're 45% of the way generating new new data. stupid. They also, like, again, because it's a billion records, they average out to 0. The average is just 0 for like everything. It's like a 0.1, 1.9, 0. And again, without the verifier, it's like we can't actually really know if this is what it's supposed to look like. Anyway, oh no, we're committing to the Git and we're saying try one. Commit. Thank you. Okay. So then next is to go, how do we make it faster? Well, I think we parse it ourselves because let's face it, the parsing is pretty easy. I'm pretty sure they don't have anything on the end. So what we can do to parse it is like fn parse value. So yeah, you take in a value, which is a stir. Now, interestingly, I could probably get away with wait, I don't actually care. I'm going to return a U64. I'm going to return an option U64 just so that I can I64, because then I get to say like return saying like something went terribly wrong, and I can just like print the value anyway, without crashing. So we're going to say okay, so we're going to say like, interestingly, we're going to say like maybe inline always, because again, we're going for fast here. So we're going to say inline always. Right. And then we're going to say fn parse pause. Right, I'm just going to take in a val stir. And this is going to also, like, again, return an option I64. Alright, and then this is going to fn parse neg. Just because I'm kind of lazy and don't want to have to like write a piece of code that goes like really too deep trying to fucking do shit. So what we're going to do is we're going to say if value dot starts with negative, then parse neg, otherwise parse positive, except we do that. Lovely. So you call those, and that's why we're inlining is because it's an if statement. I'm sure the compiler can turn that into something efficient. So we're going to say, the fun thing about past positive and past negative is we're just literally going to invert it, which I wonder if we can actually do that and say, actually we can just say, maybe just call it parse, and then we just invert it. Just go like parse, and then we just parse you, and then we parse you, but we're going to say, I think it's like map. V, and then like negative V. Alright, we just invert it. And then for parsing, because we've already cut the negative off, we don't have to worry about that. So we can say like let mute result equals 0 by 64. Right. Now for byte in byte, right? This is going to be terribly inefficient because theoretically I know every single possible value because it's 0 to 9 and full stop. But again, we're still trying to keep it a little bit. Well, we'll just do chars. Because that's the other thing is I also already know that we're in ASCII territory, which means we could actually in fact just turn it into bytes and it would work. So for C in val chars match C. So C we have 0. Well, 0, I guess 0 and full stop do nothing. 0 or dot do nothing. Here we're gonna go with a unreachable. The answer is no. Is he going to say result equals result times 10? plus 1. And oh right, so you just return an I32. It's going to crash if it's wrong. Then so then you're also just going to return an I32, which interestingly makes everything like way faster. Anyway, you just yeah. Cool. So we just need to go in here and be like, please, for the love of God, just do this times 10 plus that. Times 10 plus that. Right. And then we go down to here and we just return result. Right. So anyone who's trying to follow along with what I'm doing here, I'm getting the result, I'm setting it to 0. Pretty obvious. And then we're doing through all the characters, and basically every time we find a character, we add that character on. But before we add that character on, we multiply by 10. And what this basically does is it's like we are starting with the leftmost digit, which let's say it's 99.9 because apparently the number's common. So we start with a 9. So we go, okay, well, the value is 9. So we times 0 by and get 9, which we could again make that faster by putting that outside, like the first digit's always extracted outside. So we do that, and that gives us our 90. That gives us 0 times 10, which is nothing, plus 9. So we get 9. And then we go to the next 9. We go, okay, so now we've got 2 9s in a row. So what we do is we multiply by 10. So we multiply the first 9 by 10. Let's get to 90. Then we hit 9. So now we're at 99. Then we hit the dot, and the dot just does nothing. And then we hit the next 9, and it's the same thing. We multiply by 10. So now we put 990. And then we add 9 to 999, which is what 99.9 would be. Right? And then so we parse that here. And then we go, hey, if it started with a negative sign, strip a prefix manually. Oh, wait a second. If value dot strip prefix. If, I don't think this is the right way of doing this, but anyway. If let the prefix is minus. I'm just using Rust features now that the AI suggested anyway. So we're going to pass in parse, and otherwise we're going to pass in normal parse. And then we're going to go here and we say, hey, instead of like measurement.trim. Oh, actually, if b dot white space. I mean, technically. Ooh, no, 0 still needs to multiply by 10, doesn't it? Yeah, okay. So 0 just times by 10, and don't add 0, just multiply by 10. What? Oh, okay. But can you not get angry at me for linking shit wrong? Anyway, times by 10, not plus 10. Times by 10, thank you. Right, so we just don't add 0 because it'd be a waste of compute. So we result times 10 if we hit a 0, and anything else, which means that we just basically auto error correct in that if there's anything that's not a digit, we just don't do it. And so we parse that, which means we can come here, which means we can get rid of the trim because we don't need to check for white space, and we can also get rid of the converting back and forth. So we're just going to say parse value, and we're going to parse in measurement like this, which will then give us a number, which means we don't actually have to worry about an error condition anymore, which means that we can say something like this, because we don't have to multiply by 10 after our conversion or anything like that. So we can get the measurement, and then we can get rid of all this, and we work out what the fuck I did wrong. I removed too many brackets somewhere. I think it's like this one. Nope. Maybe it's this one. Okay, so you don't like that because, okay, so this is where I need to do some testing. So we're like I64. So we're going to turn these both into I64s, which is going to use like twice as much memory and potentially be slower. But it might also just like not be. So now we also don't need to cast that, which I wonder if that would save memory or not. Anyway, let's check to see how much faster we made it, if at all, because for all I know I made it slower. I doubt it, because I've really cut down on how we pass a number. We're not even passing it as a float anymore or casting anything back and forth, so it should, in theory, be faster. I also feel like I should just keep everything single-threaded because, let's face it, multi-threading it, although funny, I don't know if it would be worth the hassle. Or it definitely would, in which case it's like, would already be down to 2 seconds, so maybe not the sheer amount of effort it will take. Come on, come on. I should have been timing it like independently so I can like yeah, know when we're actually gonna hit the thing. That would actually be kind of funny, to spool up a thread that just tracks the time. Yeah, fuck it, we could do that. I don't know if it would actually impact our speed. Maybe we can just that. The idea being I'm going to spool up a thread before we start timing. That job is to just tell me that like this many seconds has passed. We'll do that because it seems lazy. We'll like let it's just like st thread on, and then the function is just like nothing loop std thread sleep duration from seconds 1. So outside of the loop. Right. So we're gonna go here. We're gonna say oh, it's done. Let I equal sleep equal 0. And we're gonna say print line processing records. Yeah, dot. Okay, cool. Print line. Right. So then that should just do that. And then we need some kind of way of signaling this thing to shut the fuck up. So that's done. Let static done. Atomic. So std sync atomic bool equals false. Right. Done. And then we're gonna say while not done. Dot load maybe. Relaxed maybe. And then when we get down to here we can say done dot store true. I have no idea what impact that'll have on our timing, so what we're going to do is we're just going to run that again, and we'll find out like if that impacts our timing. Oh, it did, that cleared our results. So yeah, in our log text here, ironically, that apparently didn't. It actually made it slower. Oh, we didn't plus I. Yeah. Okay. Yeah, thank you. Thank you. It was very helpful. Well, that's dumb as shit, but we'll find out if it actually impacts anything. Like the thinking being like we basically run 2 in a row, so apparently my parsing didn't make anything any faster, which is depressing. Here's the thing. Fuck you. I know. Ooh. Okay, I'd have to look at the actual input data, and I can't. Maybe we should rather me like test script that'll just generate us our input data as like a mini. If it, oh no, we don't need config test. It's just test. So this is test, and this is just going to be get snippet. Right. So no, the process phase. Okay. We're going to say do all the same stuff as getting our file, which is Right, so load our file. And then we're going to say like, it's like 1,000 lines. So like 4, yeah, except take like 1,000. And we're going to say, when out equals, again, just grab our output file. Okay, it's done. Did running that second thread slow us down? If it did, we might have to get rid of it, but we'll just keep note that it did. If anything, it made us faster. It doesn't make any fucking sense, but okay. Fair enough. It took slightly longer to write it to disk because I think the thing was still ticking in it, so it probably just like using up the buffer. Anyway, so 4 line, right. Can we say like file dot read? Is read vectored? Okay. Read to end string. Read. I have to turn into a fucking string. That means string equals string. And then we're gonna say file. Read to string. And then we say like string dot lines. Apparently you're not mutable. Right. So then we say is it right line and then out, and then don't do that because otherwise file if you use stdio right. It's called that. Okay. Just gonna run this quickly. This should just make us like a 1,000 line test file. Oh, I just pasted it into results, I guess. Oops. Whatever. We can just rename results. I just need to be able to read it is the issue. Just to like to make sure that like there's not any funny business going on. All right, I am gonna copy across that new version that should be done by now. If it's not, that'd be really weird. It's done. Yeah, it took 7 minutes and generated 15 gigabytes. So it's slightly larger than the last one. Anyway, data measurements. Let's replace our measurements to text. We'll keep the other test because it doesn't actually matter that we have this other one. I'm just curious if it's anyway, so I'm just guaranteeing that it is in fact that they are never longer than 5 characters long. Yeah, okay, cool. Are they ever shorter than 5 characters long? So I want to be like, is it like 1? Question mark. All right. So is there ever like a 0? Yeah, okay. So they can be shorter than. Damn it. So I do actually like I can't just not check. So yeah, you can have single digit ones. Okay, cool. So maybe while I'm writing these changes, I should probably like rerun the code, but with this new measurement set, and just see if they will end up 99 again. Because like, let's face it, it's gonna happen. Like, how many of these are negative 0.9? Well, just type in 99.9. No, none of them are 99.9. But that one's 99.4, which is, you know, pretty close. That's also not a point, that's a comma. Yeah, so within the first 1,000, to turn it off. Within the first 1,000, we've already hit 1. I don't know why you're highlighted. You're not right now, but so there's already 1 in the first 1,000 lines. So yeah, let's face it, like every single one's going to turn up. This is another 1,000,000 lines to go. Anyway, 30 seconds. Okay, so what was I saying? Oh, right. So what we're going to do is instead of our parsing taking in this, it's going to take in a an array of U8s, right? And then we're just going to feel like B. Then we're just going to say like error. And my thought here, we can probably just iterate it actually. Is no, can we into no? Why are they always looking? I don't want to really reference. It doesn't actually make a difference. Anyway, my thinking here is while we're doing chars, you have to actually check to make sure that they are the right shape, because chars like characters in UTF-8 can be up to 4 bytes wide, but I know that they're going to only be numbers in a full stop and potentially invalid formatting, which means that I know for a fact that I don't need to check to see if they are fancier variants of themselves, because I already know that they aren't, so I can just iterate through the bytes rather than having to actually individually check each one to make sure that the chars are the right size. You know, it took 118 seconds to run through with a new data set. I didn't actually check what the results were. Oops. Oh, that wasn't clever of me. Anyway, well, let's hope it was faster. So how's our log coming along? Terrible. So it didn't get any faster any slower. I like how we added a second thread and it got faster, and it's consistently faster. But also we had this one which is like much faster. I think that's me doing something else on the computer, to be honest. Like Rust Analyzer, also she's probably taken a lot of time. Anyway, so the min max. I do want to know if I drop them down to i32s, is it going to be faster? I mean, in theory, I could drop these all the way down to like i8s, because let's face it, the value never gets that high. Would that be faster? Would it be slower? I think i32s would be faster, but I don't think i8s would, because I think i8 would still use the same 32-bit registers. Like, I can't see. I like how I've done like literally nothing to make it faster. It's hitting slower. So what can I do to make it faster? One thing I'm trying to think is like, how do I get out of strings as quickly as possible? The issue is that they're all the fucking station names use actual UTF-8 names, like they've got fancy characters in them. So I can't just treat everything as bytes. I do actually need to know that it's not bytes first. Now, our question very much is, did I make it faster? I don't think so. It seems to not actually be any faster. Well, according to that, we're like about 5 seconds faster, which is not the kind of speed up that we want. Admittedly, I am going for like the slowest of all the speed ups in terms of like, I should really look up how to do like certain debugging things. Anyway, let's make them i32s. The issue with i32s is we will in fact have to extend them to right, keep up. i32. I think 32s are just faster. So we're gonna make, these are all 32s except, well, I know that the average never gets fucking, I know for a fact that the average never gets very far from 0, because plus or minus, you know, so why are you not just 0? My thinking is that maybe I can just make it i32, and if it overflows, we'll start again. We'll make it an i64. But like, what happens if we just make them i32s? I actually don't know if this is going to make it any faster. I mean, theoretically it should, because it should just use like way less memory. Buffering is definitely the way to go. How do I do that though? So you know, if we pass 60 seconds and it hasn't finished, then yeah, it's not really much faster. So I'm going to start looking up how to like see those fancy like profiling maps. So Rust, I think they call it fire map. Where graphs? Flame graphs. No pictures doesn't look very promising. A tracing layer for generating a whole stack trace for generating tracing is a framework for that can later be visualized by with Inferno. The fuck is Inferno? Okay. So let me go here. We could also maybe like stop saying like profile.release. So first off, up level 3 please. And debug crew, which in theory would slow down our debug bits, but anyway. I have no idea how to do this. Okay, so Inferno, like the original flag graph tool, consists of 2 stages: stack collapsing and plotting. In the original, there was a But how do I actually do this? Okay. Can I like just not do it on Windows? So it's certainly looking like Windows isn't an option. Detrace. Okay. Rust profiling. Ooh. Right, anyway, let's go back to being slow. God damn it. Alright, so we have to like buffer the input then, I think. I think. First file. I mean this file. So we read it to the string, which is just like horrendously bad. So what I'm thinking we do is we go something like, let's commit this and go like added custom parse. It did nothing. The other thing is that there's a chance that Rust is being a bit too clever and my custom parsing like did a lot if I was constrained by the speed that I could parse. Instead I'm constrained by the speed at which I can load files and therefore it did nothing. But who knows? Okay, so we're gonna say like let mute. Here's also another thing with I'm very curious if it's going to make any difference whatsoever, but I happen to know that like the maximum you're allowed, like the maximum output, so let's look at the results anyway. They're still all just 99s, so you can just fuck off. Yeah, so the maximum you can get is 10,000, so I'm going to say with capacity 10,000. Even with a capacity of 1,000, it might actually speed it up significantly just because it won't need to reallocate all the time. Like it'll start at 1,000, so it only has to like at most allocate 10 times, and it's doubling, so like 3 times. Anyway, we're gonna rewrite this bit. We're gonna say, hey, so we're gonna say like loop. Well, I guess like wow, like file.when. Okay, so interesting. We're going to say like let mute buffer, and the buffer is going to be God, it kind of needs to be a string. Sure, whatever the fuck it is a power of 2. So we're going to take 8,000 characters in. That's our buffer. So in a loop, we're going to say match file dot read mute buffer. Okay, so okay 0 break. So n do thing. I guess already we just sure, we'll just panic. So what I'm thinking is that this is our buffer. So this is yeah. So then in here we're gonna say maybe we're gonna say like let mute input equals a reference to buffer, maybe. Something like this, and then we pass in like input. If we just pass in input, and then down here we can just say it doesn't need to be mutable, except that I want to do it like that. I want to pass it in. So then we can just say that the input input equals buffer to n. Right. Okay. So we say something like actually, why don't we do that? Just input can we type correctly? Thank you. So we're gonna say like let input, and we're just gonna get rid of this input because it doesn't make sense to have it like multiple times, have to reassign it. So we're just gonna say mutable reference to buffer like this, and then we say, hey, say you return buffer. No, not to a vector. Just give me a reference to that. Right. So then that should give me like all of that. All right. So it's gonna give me like a byte array, and then because of dumb stuff, we're gonna feel like for I don't know I in 0 dot dot I do wonder what the longest possible line is, so we're going to test and go like, what is like the longest number of bytes on a line? How many characters is that I've selected? Wait, where's my character selected? 25 selected. Obviously there's way more than like a potential 25 because like the special characters and whatnot. So let's say like a maximum, like let's say 100 per line. So if we say let mute res equals 0 100 like that, maybe we'll do 64. Right. Because here's the thing, it'll either crash really early or it'll make it to the end. So we're gonna say for 0 so the 64 dot reverse. Right. We should probably also say something like let maybe use equals 0. Alright, so what I'm thinking is if input input dot len minus I, so I needs to start at like 1, I guess. Okay. Equals a new line character. So we're just gonna put comments because it's getting a bit weird. So this is the end of a line. The end of a line. For I in reverse. Yeah, so we're gonna start at the wait, no, don't reverse. So it's just 0 to 64. Except and then like +1. I would rather the 1 be here. Like let's go like 1 to 65, because then we only have to subtract 1 once instead of adding 1 every time. So if it's this is the end of the line, else we just continue. Cool. All right. So and you break. So what we need to do is say like res equals I mean technically you just become a reference to, I guess, like buffer 0 maybe? I don't want to, no, there's something, I just want like a reference that might become valid. I don't know. How do I do that? Do we just like none? There, and then we say sum. Sure. Okay. Strange. Like your reference. It's the length minus I to the end. Which is saying like basically the character after the new line character, and like don't try and do an unwrap, just do that. Right. And then you just need a break. All right. So this is the end of the line. Store everything after this, after the new line, for the next read. All right. Okay, then we break out of this. So this loop here seems kind of terrible. Anyway, it's really inefficient. So then we're going to say, oh, we've done that, we've broken out. So I don't think you actually get used. So then we need to do some logic of like, I kind of do feel like I need to copy the bytes of input to the beginning of the buffer, but that seems like a dumb thing to do. I mean, but maybe we could do it. So if we go like here and we say if let sum prev equals take, yep, okay. So that sets that back to none, cool. And then buffer.prev links copy from slice previous, okay, that's what we want. And then we want to say that new prev reserve. Okay. Maybe we should just put it here, and we just say prev.len. Right, like that. Just then prev down. We say let used, like this. Right. Something like that. Else 0. Like that. Cool. So we're going to take used, and we're going to say hey used, and then I guess you're used plus n. Yeah, because there's a number of bytes written. Right. I mean, technically it would be n plus used. So, and then we check from the end back in to reset our results. Basically, we're going, if we don't end on a new line character, like if we're not exactly on a new line character, then buffer those characters away for the next read, and then at the beginning, if we've got previous characters from the previous loop, write those away, please. Yes, that is your type. Thank you. Buffer, wait, what? Cannot borrow buffer is mutable because it's already borrowed as immutable. Where though? Here? No. Ah, damn it. So can we just make you, alright, I need you to be a maybe a vector of viewings. So this is fine. Fuck you. You're just gonna equal a vector. No, this is a vector of U8s. So it's with capacity 64. Right, so we only have a reserve. Okay. So if you're not empty, then buffer reserve len copy reserve.len, and then otherwise when we get to here we're gonna say, hey, you're actually no, we're gonna say res.clear. We should probably do that immediately after this. Like once we've copied it in, that's what you do. You say res dot ooh, okay. Alright, fine. Res dot clear. Right, like this. And then when we get to here, we're gonna say, hey, res dot extend from slice. Maybe. I'm gonna need to print this out like on the first loop, just to make sure that it's actually doing what I think it is. So like first. True. Okay, so then we're gonna say if first, let's say like we do like print line last 64, which is going to be a and it's going to be input length minus 64 to the end. I don't care about setting first to false. When we get to here, we're going to say first to false. Right, okay. So then when we get to here, we're going to say, hey, for I in da 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 da. When you get to here, we're going to say print line reserve the next read, and then we do this, and we're just going to paste out reserve. Now I need to make sure that the reserved is exactly the same as the, like, you know, what characters it was reserving from, but also that reserve is brain's not working. How do I phrase this? So like we need to make sure that the reserved is those 64, but also that the reserve doesn't contain the new line, because otherwise that will kind of break shit, because we'd start on a new line. We want the new line. we're gonna need the new line to oh. First off, why the fuck are you printing every single time? Oh, because we're printing reserved every single time. Yeah. Okay. If first, please tell me that I reserved so much. Okay. So cool. So what we said is the last 64 with this, and I don't remember what the new line character is. I think it's 14 or something, isn't it? Does it tell me when I hover over a new line? It is A, which is 10. So reserve starts with 10, as you can see, which is not the best, because A. Yeah. So that means we need to be so you're the correct check. You just need to like do +1. Let's try that and go, hey. So now you're only like, yeah, you're like the 66. All right. Sure. So what we're going to do is we're going to set first to 0, and then we're going to say if first equals 0, if first, well, more like if first is less than 2. First is less than 2, and then first plus equals 1. Right, so this should then print us the first 2, and then we can check to make sure that the if I don't think it's doing anything, it's just reading everything in. First equals, if first equals 1, reserved bytes from the last read input and then used. Cool. That's actually exactly what I want. I want to make sure that Reserve bytes from last round. So 6, 9. Yep, right. Reserve 16 bytes. 6, 9, 3, 10, 2, 2, 2, 2, 2, 5. I'm reserving 4 bytes for the next read. Hey, okay, cool. You better not actually be finishing 4 seconds. Oh my god, really? It's not printing any. Oh, right, because we're not actually doing anything. I was going, fucking, that's a real speed up if it takes 4 seconds. Anyway, we don't need to print that out every time. We don't need to print that out every time. And we don't need to care about tracking first anymore. Right, so I'm almost certain that we are in fact doing our thing. So then we're going to say like, right. Annoyingly, I think we just have to parse. So I'm gonna like break it into a lot of functions. So I'm gonna like parse buffer, I guess. We have to call them different things. Buff, which is then gonna take in a reference to a U8. Right, and it also needs to take in our store, which is a mute reference to the index map. Right, so this is to do. Right, so we've done this, and then we're going to say, hey, can we parse buff and it just, well, can we update input when we do this? Say here, and we say used, and then we say input here. Can we say like you're actually mute like this, and we can be like, hey, when we get to here, can we say that input equals input, yeah, from the beginning, like to that, right? I think. So then that should then like be like, if we do end up cutting a character, then we store the buffer and we pass the buffer down into you. Okay, and then we go, and then we loop. So your job is to work out what the, okay. So we need to then call like let, okay, so we're going to call you, I guess we call you mute, I guess, because we'll be overriding you with a new pointer. So we're going to say, while buff.len greater than 0, something like that. Then we're going to say, annoyingly, it still takes ages to load it, but we are doing only 8k at a time. Anyway, so while buff len is greater than 0, and like let station measurement and rest equal well, I guess we could probably actually just do that. Feel like while let equals extract buff. All right, and then we say that buff equals rest. It's like the very first thing we do. All right, so we're gonna say fn extract, which is then gonna take in our buffer. It's gonna return a pointed to a U8. U8, and then I'll point it U8. It's just gonna return 3 sets of buffers because I at this point I'm just trying to like work out what I want to do. So inline always. I think you also, yeah, inline. Right. So what we're gonna do is we're gonna say like loop. We're gonna say let I guess mute phase equals 0. Let mute city equals sure, just the whole buffer. Miscellaneous and left equals buffer. Right. We're gonna say like maybe maybe say like 4 I be in buff dot getter enumerate like so. Then we're going to match phase. Right, and we're going to say, hey, if phase is 0, if if phase is 0, it's like this, isn't it? If b equals what do we want? So it says like a semicolon. Yeah, semicolon. Okay. Then do that. So put phase 0 in this and this. So then we say that city equals buffer to I. Okay, and then left is I plus 1 to the end. Okay. I don't know what this mismatch type UA. Oh, it probably needs to be a binary. Like that. Cool. Reference you. Shut the fuck up. All right, and then so the phase and then phase plus equals 1. Phase equals 1. Okay, so then 1. If b equals binary new line. Measurement equals city len plus 1 to I. Yeah, that works. Left. Okay, so maybe we don't do that. I was going to use left right for that thing, and then we return city measurement left. We get to here and say panic. Invalid format. Okay. I mean, so technically we don't actually need left then, and we can just return buffer I plus 1. Maybe that doesn't seem right. I think we should panic here. Invalid format. No, maybe more like panic out of EOF end of file. Cool. Alright. We didn't apparently we just say like you just equal buff and you also just equal buff. Okay, I think. But, oh wait, I can just do this, can't I? Maybe. Can I just do that? I wonder if you're going to have a problem with me doing this as well. I'm basically just saying like these values are unassigned. Yeah, because and then I use it. Okay. Since I return buff as soon as I assign it, I don't have to worry about that. You need to mute. Okay. Right. So that calls extract, which then gives us our station and our measurement. We can then, I guess, yeah, buff equals rest. The very first thing we do. is go, hey, the buff. Oh, you too far. Okay, so we have this, and then we're gonna say I think there's no need to convert it back into a string. Maybe we could just do it unchecked, because we do know it's a valid string. We can like let station. Well, let name equals std stir. I don't know, like string from UTF-8 unchecked station. Right, so I'm pretty sure this is unsafe. Yep. Unsafe. Okay, station. We have to like dereference you then? Okay, cool. No? Oh, you need to be a vector, okay. Okay. So I'm gonna do this. Now theoretically I think I can get away with probably sticking them into the measurements table as a vector. But anyway, I'm gonna say let measure. Oh, what was it? Let temp equal measurement. We'll do parse. Parse. Yeah, parse text in bytes. Yeah. Okay, so I need to modify you to take in U8, and then you're just gonna if value 0 equals this and that. Okay. Green like always. Okay, so we're gonna parse you, and parsing you parsing you with the measurement should give us our temperature, and then we can say no temp dot entry dot min equals max equals max. Irrelevant let pattern. What do you mean irrelevant let pattern? Pattern will always match. I know that's what. Oh, is that how we're supposed to? Right. It's supposed to be like an option. Like that's what I was going for, like option, and then when you get to here, you return none. Some. Something like that. Okay, cool. I mean, that should work. I probably should have like got it to print out a bunch of results so I know that it works. Why did you not? Panic candle, call once. What did you call? Where did you panic? You panicked at parse file. What do you mean? How does that work? Okay, anyway. Try this. Okay. Invalid format. Can I get you to print line buffer? Well, first off, how did you get here? Can we I guess we want to debug some stuff. Debug phase city measure. We can't. Measurement should definitely not be assigned. Yeah, measurement is definitely not assigned. So, oh, you printed out a lot of stuff. Why are you just like not? Oh, because you get to hear if either of those is wrong. So it's more like we want to say match B. B, okay, so B is a semicolon. If phase equals 0, then do this. We need to go the other way, because otherwise it's like if you're in the phase, if you're in the phase but you're not hitting the thing, if n and then phase 1, it was like hitting everything else, which is we need like panic, maybe. No, we did not do anything technically, because it's perfectly valid to get to those places without being in phase. It's probably smarter to use just if statements. They might be quicker. All right, 17, 18, 19. I feel like multi-threading is going to be the only way to get it down particularly fast, but we can also just make our buffer bigger, because the fact that it still takes 4 seconds just to read the file and do nothing with it. Here's the other thing. This lets me multi-thread in that, like much more easily, in that I can throw the chunks into the thread pool, like into a thread pool now, because I know that the chunks contain full lines. And then we can return. I feel like hashing is too strong at the moment, like or too aggressive or whatever. We can swap from strings. I think we swap from string to buffers of vectors. Again, I don't know if it's cheating to run through this and work out what is the absolute minimum number of bytes required to make a unique thing. I mean, we've got it down to 85 seconds. The averages look very wrong now. The minimums are definitely not getting calculated correctly. They're all getting set to 0. Which is kind of funny, but why are you not picking up? Did you put an M dash instead of a minus sign? Probably. What's the bet that the AI put an M? Oh, wait, we never call parse value, we just call parse. That would also cause issues. Where is it? Parse. Somewhere. So we extract, and then extract returns that, and then here we call parse. It's not parse, it's parse value, because otherwise we don't do the negative positive shit. Also, can I just inline this as well? Would it take 85 seconds? Inline with. Where's our log? So it took 85 seconds. Let's get rid of these ones, because these are just invalid. They were just the wrong thing. I mean, it's a 25% speed up for basically doing nothing, but reading it as binary instead of strings. I mean, technically we're also buffering it, but that's more because actually I wonder how much of a speed up we would get if we just. So let's not chunk it, and let's just read it in as a vector and then do that. Because technically that would be the next step, and I'll call it that, and then. So let's go to a log, and let's go. This is 8K chunk. That's 8K chunks. We'll find out how long this takes. I don't know what this is. I don't know what I changed. Oh, all right. This is the next one will be 8K chunks, because it's technically we didn't check the negative positive on them. Anyway. And then I modified this to be inline, so I kind of want to see if it actually makes a difference. Anyway, it shouldn't make that much of a difference. It's like an if statement per line. Ooh, yeah, it added 1 second. So unlikely. Anyway, we'll immediately run that again and see if that inlining the parse function made any difference. Again, unlikely. But anyway, we're going to say that this is the 8K chunk, so we're going to get rid of this one, because technically you can you were an invalid test because you returned the wrong values. I should have also checked that you were returning the correct values. But anyway, so what's next? So do it. All right, it's gonna just like. So what I need to do is I need to like cut this, paste it back because we're still going to use it. But anyway, so instead of doing that, we're going to say, instead of doing this whole loop, get rid of the loop. The buffer is just going to be a vector with capacity, I don't know, file.size, metadata, unwrap.len. As unit sign. Okay. So then we're going to get rid of the reserved, the used, the clear, all the input shit, all this goes. We're just going to say file.read to end buffer, and then we do that, and then we just parse in a reference to buffer like that. And we go, I wonder how long that's going to take. Something tells me slightly faster. If it gets slower. I think it's because I'm doing other things, like modifying stuff with the Rust analyzer. I must be using up bits of CPU that then slows it down because it's like it fluctuates by a second or two with like no changes. Like it's, but admittedly, over a minute and a half, me doing stuff on my computer could fluctuate the available CPU. Uses a bit more memory doing this. Yeah. So this time we're loading up the whole but let's go here. I'm gonna wait for it to finish. So that, yeah, that's still 8k chunks. Where's our log? I'll have to rewrite it because if I paste, if I copy, I'll lose my thing. So it's like 8 chunk. I'm gonna wait for this failure to come in. I'm curious. This should maybe be like, I want to say like maybe 95 seconds because I reckon it's gonna be slower than chunk. Maybe not though, because technically I'm not running it in parallel, so I'm just buffering the whole thing in one go. So it might actually be faster than doing the 8k chunks, and because we're doing like no multitasking in terms of like the 8k chunks. Just so it could actually end up being faster. We'll find out. Or it's going to be exactly the same length because it like got optimized or something. It's exactly the same. Okay, so this is read. And that technically goes there because technically that would have been what I should have tried first. I just skipped straight to chunking it. So we're going to commit that. We're going to say technically these two lines don't exist yet, so this is going to be here. I'm going to say read bytes instead of chars. Okay, correct that. Because then we can go back and do our chunking again. Alright, so that means we go back to main here and we go parse file and paste this in. Alright, so this is our so this is here. I'm gonna go parse as 8k chunks. Okay, now again, it's gonna well, we probably should have we're gonna amend this and put our results in there as well. Okay, cool. Now the thing with that is it's not really doing anything because we're parsing them still single threaded, but in theory this should make it really easy for us to go like I don't know how to make a thread pool for thread ste wait os thread raw windows thread anyway thread scope thread id thread pool no pool. Can I I want to say it's like Bevy task or something. Bevy something. Let's look it up. Bevy task. Oh, tasks. I want to get the thread pool because I'm lazy. Compute task pool. Yeah. Alright. It's called Bevy tasks. And equals this. So we're gonna bring in like a Bevy crate because I'm too lazy to actually make my own thread pool, and then we're gonna go, hey, like, can we be like let pool equal Bevy tasks task pool. I want to say it's a compute task pool, but it could be just a task pool because I think the compute task pool is just a task pool that's already configured. Maybe. Maybe it's not. It's a take, isn't it? Task pool. What the fuck does this do? Compute task pool. Again, you just put capitalized words there. Task pool. So meta ident static. So static. Okay. So once lock task pool. Yeah. So it's literally just a task pool, and it's just a static task pool. So I don't actually need to do that. Getter init try get. Okay. So I believe we can just spool up a task pool. Task pool. Maybe. No. A thread pool for executing tasks. Tasks are futures that are being automatically driven by the pool of threads owned by the pool, in the case main thread only. In this case, main thread only. What? What do you mean in this case main thread only? What do you mean? In this case, main thread only. Have I got a feature turned on? Single threaded taskboard. No. Okay, we have to go up a layer. I don't know what's up a layer though. Single threaded taskboard. So that'd be in a lib. Where the fuck is single threaded taskboard coming from? Multi-threaded config. Multi-threaded switch. If okay. Version. Features. Multi-thread. You're gonna actually like let me do it this time. Hey, there we go. Now we have an executor and threads and shutdown. Okay, so we're gonna go. What was the thing? It was like a get thread executor, new spawn. Okay, so if I said new, what does that give me? New. Okay, task pool build a new dot build. Right, what does a new one to use? That gives me default. What is the default value for you? What is the default? If set will set up the thread pool to use at most number of threads, otherwise uses the logical core count of the system. Okay, cool. So we just don't do anything. Bevy takes the best. Stack size. If set will use using stack size, otherwise use default. And thread name. Okay, yeah, don't care. Okay, so what do we do? Like pool dot spawn, and do you return a task? Okay. And what else is there? Spool. Here's the thing. Thread number. So it will do as many tasks as it can. So my thinking is because each line is going to be like a variable length, and we're chewing through each one. We probably want, I don't know. So we have like 16 gigabyte file, right? Measurements.txt. Yeah, it's like 16 gigabytes. So 1024. So that's 1K. 1024. So that's 1 meg times 1000. That's 1 gig. So times 15.76. So we have like 17 billion bytes to go through, and then that implies that each line's on average 17 bytes. Okay, anyway. So we're going to divide that by the, I think I'm going to say like 30 something cores. What have I got? 30 logical processors, 32. So we could give each one, what was it? We can give them 500 meg, and then it would, like each thread would go through. Okay, so let's give them 1 meg, which is 1024 times 1024. So this is 1 megabyte buffer. Okay. So task pool. So when we get to here, we're going to say, hey, I'm going to say that you don't get given this. You don't get a store. You instead are going to return a so you just take in a buffer. But then I don't know, because how many are likely to be stored in 1 megabyte? How big is this file? Revealing file. That's 16K, and that's 1,000 lines. So, okay. 1,000 lines, correct? Yeah. Okay. My concern with it being 1,000 lines is that implies that like we could in theory get up to 1,000 in a vector. We could parse everything and dump it into a measurement, but that seems like a really dumb idea. But also going through a hash on everything is going to be like really, really slow. So we know we're going to get like at least duplicates of everything, because there's only like 10,000 and we're giving it 16. So yeah, so we're likely to have duplicates of everything. I don't actually know how much is going to be there. The pass buffer is going to return an index map. I think a hash map is faster. I don't actually know, but we're going to return a hash map because we can then insert all that into the index map. And the reason we're using the index map is because let store equals capacity. Sure. Where are you getting that 819 from? Better not be cheating. I think the AI read the number of lines in this file. 8895. So let's give it 10,000 with capacity 10,000. Because again, we know that the maximum is 10,000 because that's actually like one of the specifications of the thing is that there can be up to 10,000 weather stations. So then we do this and we do this and we do this and we go, okay, so store and store.entry, and then we return store. Like that. Right. So entry. Like that. Okay, cool. So with a capacity of 10,000, we do that, and we're going to push you back. So then what we're going to do is we're going to say task equal task or spawn 50. That's not how that works anyway. Spawn a first buff. Can I just pass in that? Does that work? No, it has to be. Well, you actually, first off, you need to be given buffer. Ooh, okay. So we're going to say that you actually take in. For convenience, we're going to say. Ooh, actually, no, because we don't know how big it'll be. God damn it. So you get given a buffer. So, annoyingly, we're going to go like, you get this, you get this. I'm going to say like async. Maybe? I don't know if it needs async. Buff equal buffer. And then you pass in a reference to the buffer. Yeah, it lives outside, so we're going to say that a buff equal std mem take. Right. Can I not take that? Swap. And then just feel like mute this. No. can't do that because you're already borrowed immutable. Oh, God damn it. Why are you still borrowed immediately though? Oh, actually, we should technically we should be using input. Yeah. Okay. Technically, we should be taking input. I mean, so we have the buffer. We copy that into the buffer. Right, that's fine. And then so then we've got the mute input here, and then we do all this, and we go here. Okay, so technically it would be that we want to take. So we don't actually want input. We just want to say like let input equal, and so the input's then going to equal like n plus used, right? And then it's like, hey, buffer input minus I, and then extend from slice buffer I plus the input. That doesn't seem right. To the end, I think the AI stuck that in there. Yeah, from you to the end, and then we say the input is my input minus 1 plus. Okay, so yeah, we shift it back the amount that we took out. Okay, so the A buff is going to be, we're going to swap the buffer. Okay. Okay, and we're going to say like let. So A buff is going to equal I'm going to say buffer.clone, right? Like that's the thing that we can we like input.clone. I don't want to vec, I want clone. Cloned maybe? Okay, yeah, it's gonna give me a vec. Okay. So we do that and we say task, and then we say, hey, so you get a buff. And then we're just gonna go like you get access to buff, I guess. I don't know. And then we don't do this anymore. So that should give us the task, and then I believe that should execute the task. So you need to be mutable because we can reassign to you. Okay. So you do this, then we have the task, and then we're gonna go something like do you have like a list of the tasks? There's threads and executors. So when I say spawn, pull.spawn, do you actually like do any task new executor spawn? So executor spawn, do you keep track of stay active? Like I'm curious if I can get these tasks back without having to actually own them. Like if I said task dot detach, do I ever get it back? Maybe not. I don't think so. So pull.spawn. So like can we like pull.tasks? No. So we've scoped with executor spawn local. I mean we could scope them. I think scoping would actually allows spawning on-state function on the thread pool. The function take a callback past a scoped object into the other scope provides the callback can be used to spawn tasks in the future. Okay, so yeah, let's just fucking use a vector. Let me vec tasks. And this is going to equal a vector new. No, we're going to say like with capacity, and this is going to be file.len dot metadata dot unwrap.len divided by, let's make a const up here, const buffer size, which is this, which is in this, which is buffer size, and then divide by buffer size as you do times 3. No, it's as okay. I think they're executing the order, so I'm probably times 2 actually. So the idea of the times 2 is just that I suspect that because we are carrying over certain amounts of like reserved, we're never going to use more than half of a buffer. I mean, we could probably just +1. What are the odds that we're going to fucking +1? Yeah, cool. So the idea being that, like, in theory, we should take no more than this many tasks. Tasks dot push task, right? And then at the end, we need to aggregate everything. So for tasking tasks, parallel task dot wait. No, I'm pretty sure we can say like task dot is finished. No, it's like is it Bevy task? No, is it wait on? There's definitely a way to block on. Yeah. Block on. Alright, so this just blocks the current thread on a future. And so we can say like block on task. Do you then return the value of the task? Yes. You do. Okay. So we can then like aggregate. First off, we don't need to set you until like right down here. Or also we can say like on. I'm gonna say we know how many there will be, but we actually have no idea because we know how many tasks we spun up. We don't know how many tasks, how many different cities you can touch. Okay. So we're gonna say like actually we have my chat with them. We're gonna say. I have no idea why I had like a second stream on because YouTube lets you stream onto like shorts now apparently, just like, but it doesn't let you move the screen, so like people in shorts just don't even see anything interesting. They see like half of a fucking, they just see all the errors. They can't because I can't actually move where it is. Anyway, it's dumped. Anyway, so we don't actually know how many there are. So anyways, we're gonna take each task, we're gonna block on the task, and then we're gonna say measurements dot extend. Extend out dot train. I think that's correct. Yeah. So extend means that like whatever this iterator returns, put it into this hash map or this index map because that means we can sort it. Also, don't think I've been sorting them, have I? Oh no, yeah, I could return up here to sort it. Yeah. So the measurement index map. So we block on the task. When the task is done, we feed it into the measurement, into measurements, and so extend it. And drain means like remove them from the map. Don't like iterate through or make a copy. Like just take them out of the map as you go. So this map will then be empty by the time the drain's done, which means that this will have all the instances. Not quite right because that'll override everything. God damn it. Right. So we're gonna say for KV in drain entry. Yeah, entry default control.count plus count total plus total. Min is the min of the mins and the max is the max of the max. Okay. So then that should smush them all into that. And then let's see how long this takes. It's gonna have to compile a lot more shit because it's gonna bring a lot of Bevy stuff in and then okay, so the thread overflowed its stack because apparently 1 megabyte is too big. So let's go with like 50k, 500. Okay. I don't know how big the default stack size is. Less than 500k. So to 7 seconds, 8 seconds. It's not that much fun, which does imply that it's either I'm doing something very wrong. No, it's just not doing very much. So also, fuck me, like it's using way more memory. Something's not quite right. Anyway, the fact that they're not all running, like not every CPU is pegged, means that it's just not actually doing what it's supposed to be doing. I have in fact run out of memory. So that's fun. I don't know what's using such horrendous amounts of memory because it shouldn't use very much more memory than the doing it like single threaded. But, we're starting to get some memory freed up, which means we're starting to finish tasks. Yeah, again, it's not doing anything. Did I not, like, start the tasks? Maybe if we get to 85 seconds and it's still not done, that just implies we didn't start the tasks somehow. If the result is not required, one may use to do it. Okay. For that purpose, is often stored in. Okay. While futures usually need to be polled to be executed, Bevy tasks are being automatically driven by the pool of threads owned by. Yeah, okay. So something tells me that it's just never going to finish because it's just not executing the task. Well, it has to be doing something. It's freeing up memory. Just like really slow. It's just not like 99.9% of them is not doing it. It took 120 seconds, so my multi-threading made it like slower, which is fine. So question one, like if we make it like 100k, run it again, does it just use up even more memory? I think it's just going to use up even more memory because it's not actually, it didn't do anything. I just made each thread get less memory, and they're not executing. Why are they not executing? Can I like print out some diagnostic stuff? Yeah. Cool. So we're gonna say like debug. Can I debug the pool? I don't think so. Oh, actually that actually worked. Okay, never mind. Let's just stop this and run this and go. Hey, nope. Fine. Debug a reference with the pool. Okay, so we have an executor and then we have lots of threads and a shutdown transmitter sender. But why are they not all running? So thread executor. So what's the bet that they've got some kind of like fucking stupid thing that's like Bevy task, task pool builder, new dot, on thread spawn, sets a callback that is invoked once for every called thread as it starts. This is called on a thread, on the thread itself, and has access to all the thread's local storage. This will block running async tasks on the thread until callback completes. Can we do something like print line start task? It doesn't seem to be doing anything. So stack size on thread. Maybe they're all just crashing. On thread destroy on, because there's a good chance that the stack size just isn't big enough for the size of the thing. Anyway, let's do this and go. How quickly does it just fill everything up? Apparently very slowly, because this is on. Or did they just all? Okay. So that's only when they spawn, and it doesn't mean shit. Okay. Okay, the return task is a feature that can be polled for the result. It can also be cancelled or detached, allowing the task to continue running even if dropped. In any case, the pool will execute the task without, even without polling by the end user. Yeah, but it's not doing anything. Can I get you to print one? Can we do this? Are you actually going to tell me that you're running these things? You are? Okay. It's just not using any CPU. So I don't understand. Now, my thought is maybe that I'm just, we go like the task pool builder. So when we say like new default, new, okay. When we say new internals, task pool, new internal self. Task pool builder, new internal. So we have the shutdown, and this is an async channel, and then the executor, which is an arc new create executor. Okay. Provides a fundamental executor primitive for the target platform. This piece of default, the async executor feature will be enabled, which will rely on async executor delaying implementation. This requires SB, no serious required context invalid. You must use an edge executor, which executes the backend. Executor wraps a multi-threaded async executor. Spawning will generally require tasks to send a single line multiple threads to task. If you require an executor without send sync required, consider using a local executor instead. Okay. But my question, async executor, is why the fuck are you not doing what I want? Like, it has lots of tasks, lots of threads running. Like, so why are they just... My only thing is that, like, possibly when I call spawn, something's getting stuck somewhere, but it's definitely, like, fucking queuing everything. Processing records, it said, yeah, to 140 seconds. It's pretty slow. Now, part of that is because I'm fucking printing everything out. Anyway, we're going to say let... Oh, we can just get to the end and we can just say, when we get to here, we're going to print line, all tasks spawned. Can we make this a little bit bigger and say like 250 kilobytes? So it should shrink down the number it makes. Now, I want to say that maybe only print these when you're finished. Can you also maybe take in ID? ID equals thread. I suspect maybe I missed a move somewhere and it's just not actually like being async. No, we want to say tasks dot when on this, and then we want to say something like this, and then we want to say ID. That ID equal tasks.len, and then we just do that. Okay, why are you not liking this? Move as async move then? Async move? Okay. So now you grab that, and I do wonder if maybe that's what the issue was, is that you were keeping that. Would be interesting if that was the problem. These do feel like they're going a lot faster now. It's still not actually using like anything. Like, how many is it spawning? Can we say, like, maybe don't print this for now. We're just gonna go like release. Here's the interesting thing, isn't it? You printed that, right? Debug pool. But you never printed this. So the question then becomes, is it hardware? Like, it's clearly not reading my disk. Like, it did read the disk quite a bit, which I think is on my Y drive. Sure. Okay, it read the disk a lot. but it's not actually doing anything with it. Like, at no point did it print out all tasks spawned, which means that it's still in this loop somewhere. It's either stuck. Either stuck in a loop, in the loop. Actually, yeah, that's good. That's a good point. When do I break out of this loop? Never. Yeah, good call. Good call. Why am I looping? Question. So used. Oh no, I do. Okay, so. Can I get you to like maybe print here? Like, I feel like it's getting stuck somehow and it's like not reading very much data. It's reading lots and lots of bytes. 250k. The question then becomes like how many so 255. Okay, so we're gonna go like calculator. And what was it? It was like 10 24 to the power 3 gives us gigabytes times 16 gives us the amount, so 17 billion, which then we divide by 255,999. It's going to take 67,000 threads. So bigger. Right. So it can't do 1 megabyte for some reason. Now maybe I changed something and it can do 1 megabyte now, because I definitely changed something. I just don't think it can because it's the yeah, it's over so low stack. So what if I instead said what if I said this is just a vector with capacity buffer size, because this will put it on the stack instead, on the heap instead of the stack, and let's face it, that's going to be just as fast because we're passing it off. So to the end, I don't know, does that work, or is it just going to keep trying to fucking read start task? Well, no, that's it's. I think it's just trying to read forever. All tasks spawn to 0. Okay. Read. I don't, yeah, because I don't think I can specify a certain thing. With capacity. Can I maybe do like vec 0.8 buffer size? Maybe that'll work. It needs to, okay. Yeah, there we go. Now we're getting megabytes at a time, which reduces this by 4. So, oh, that's wrong. Anyway, it's like 17 billion. It's like the number of bytes. 17 billion. And look at that. It spawned all 1,000. There's our answer. It's 16,000. Now, it took 24 seconds. Okay, so all it took was just actually managing to put all the fucking stuff onto the disk. Like, yeah, alright. So we got down to 23 seconds. So let's go to our logging and say, hey, first off, this one I think I crashed something. That didn't even work. Bad multi. Right. Okay, multi. So this is 1 megabyte chunk. Actually, is it 1 megabyte? Yeah, 1 megabyte chunk. Multi. Okay. So, what's interesting about it is we could probably swap the memory now. See, because that's the thing. So I'm pretty sure the way that this macro works is create, yeah, into boxed like this. So it's doing some kind of like memory magic. All right. So first off, like, what happens if we like go like, what is it? 16,000. So it's like 100 times. It's like 100 megabyte buffers. Go. See, the trick with this one is I don't think the it also is in fact still printing out of the console. It only took 8 seconds. None of them capped out, which means that it's technically it's that we can't read in data fast enough, which is ironic. So how many tasks did it do? All tasks 100. Oh no, it only got down to 160. So we can technically make it 4 times larger again. The issue with making it 4 times larger again, because that's going to bring us down to. Okay, actually, let's make it like the maximum size we can. So that's 162 divided by 32. 162 divided by 32. We can make it 5 times larger. So let's go and make it 5 times larger. The issue with making it 5 times larger is that there's a good chance that we just won't actually make enough memory. Like, we just, like, they will probably be finished before the, you know, by the time it's loaded in one, do all the cores cap out. No. In fact, it takes longer. Oh, the irony, because it takes so much longer to read in a file that it's actually like these don't even get to start up before like another thread's already done and it takes it. So what were they doing? Oh, I was putting notes into the log. So this is 100 MB chunk multi. And this here, this is 500 MB chunks multi. So I do wonder like where the tipping point is, because something tells me that like maybe 50 megabytes is better. I should probably also be picking a pair of 2. And maybe not printing the console, because let's face it, that's probably like half the time. So 300 tasks, and it finished in like 8 seconds. So, was that faster? Yes, technically that was faster. So, than the 100 megabytes. So this is 50 MB. Right. So, we should also maybe like do multitasks -1 so that I don't fucking have my main thread doing it. No, I don't know. Anyway, let's just like stop printing to the console. We also know it won't error, so in theory we could just like not care. So why are you still printing start task on every thread? No. Cool. So it took 7 seconds. Yes. So this is 50 MB chunks, no logging. Multi. But we should probably run it again and like put that comment here on the next line and delete this line, because I still had a lot of logging turned on for no reason. Let's go back and forth. No, just close this, don't save, reopen it, and go hello. It got slower. Okay, so we're just going to call that no logging, because that's probably variance in the noise. All right, so I do wonder is if it would be faster to not do this check. Anyway, we also like don't need like this or this. So to owned, I wonder if I can I be like std mem swap. Okay, so first off, I need you to be a vec, not input. I mean, I could, but buffer service, right? And then we're gonna say std, because I think I'm cloning something, which I think is like very inefficient because I'm like then overriding it. So mem swap mute buffer and AD buffer. Yeah, you can't borrow anything. Right, so now I'm just swapping pointers to these, like this position and this position. I just swapping pointers. I instantiate this somewhere off into the distance. Yeah. And then we give it the task, and we can probably also like not bother with assigning to then drop. Right, and then have you fall through. All right. So the next question is like, can we maybe do something more efficient? I have to commit this at some point. Oh yeah, it only took 6 seconds. Okay. So let's undo. So because again, like if someone wants to like watch the YouTube or the VOD and like, or like go through the Git, I kind of want this to be like, if you follow along, you can keep track. So if we save that and then we go to GitHub and we can say, hey, this is add multi. Also, can we just like stop with the lock anyway? So added multi-threading. This is all my multi-threading stuff. Cool. Okay, commit. All right. So then we need to go like Control Y until we fix it. Okay. I think technically that had a really low log value. Yeah, that's 6 seconds. Anyway, the 6 second is it can stay on there. This is 50 MB chunks swap mem swap. Alright, cool. Again, I still actually have no fucking idea where our slow spot is. So we're spawning 330 tasks. So I don't know what this number turns into. Yeah. Something tells me if I drop this down like maybe 32, it'll be even faster. Like a power of 2. Something tells me a power of 2 will be faster, but it might be go up to 64. It kind of depends. Okay, is that faster? Yes. But it's the same speed as that one, so it's within variant. Alright, let's go with 64. See, the fact that they're not actually changing speed very much tells me that it's like, we have bigger issues. And again, nothing's getting capped out, which means it is in 7 seconds, so it's slower. So maybe actually dropping down to 16. They're getting slower. So let's go down to 8, actually. 8 megabyte. Oh, actually, I could probably look at my CPU and be like, if we drop down to 2 megabyte, that's apparently the local cache on the smallest scale. So that should like load like all of the memory. 32 and that size, so it still took 7, which is annoying. 7, really? It's getting slower. I think as soon as we cross the threshold of like 2, it might actually speed up again, because that should like maybe fit into a cache line, or like onto like each individual core will have its own 8,000 tasks. Nah, see the number of tasks is getting too high now. It's taking too long. All right, so. So we're just going to go to our logs and again like record things of like this here. This is 2 MB and this is 16. What's our fastest? I don't remember where you were. I think you were 32. There's a trick being that the best choice is the biggest that can still be done in time, because again, like none of our cores are actually getting capped out. So if we can get data to the cores faster, they're just a little bit too quick, to be honest. How would I even load it faster though? Like it's somewhere in this loop. If we could remove the need to trim, that might help too. But the fact that I'm copying this data around so much is also probably. Ooh. Wait a second. Can I like potentially, right? Like when we make this buffer, if I fill this buffer with this buffer, that might work. So what we want to do is go something like let a buffer equal, no, because that doesn't stay across frames. I mean, well, the thing is we don't actually need this used empty if we do this. So what we're going to do is we're going to say something like let the input equal, and then so used needs to go up here. So we need to be like let used is equal to 0. So what we're going to do is we're going to say hey used, and then you're going to say hey it's a break and used. Okay, so then we're going to go, our input just tells us how much we actually, you know, our end. How many bytes did we actually read? Which is like in plus use. Okay, so we have this, and then we're going to say something like for I in 0 dot dot no buffer dot dot input dot jitter dot reverse dot enumerate, maybe I b. Here's the thing, I think for each would be faster because I think that lets the compiler honestly like for each, I want to say lets the compiler know that that like you aren't interacting with outside variables, except technically I am. So we're going to say something like also we don't want a for each because we don't want to run them in a row. Anyway, we're going to say if b equals this, except can you like reference b like this? Okay. So if b equals new line, used equals I. Right. Then I don't care about you. Okay. So used equals I, which then should do all of this bit. Right. So this is just like a better way of extracting our used. Then we're going to say, hey, you're equal to this. Then we're going to say then we're going to say dot dot input minus used dot copy from slice. Did I commit this before I fuck around too much? I believe so, because everything I'm changing is just small. Yeah, okay. I must have committed something. So abs dot dot, so input, which is the end, minus used, because we're going to cut that off. Wait, what? No. It's u dot 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 is equal to, is copy from slice. So the beginning of u is equal to buffer input minus used to input. Right. So then that should, in theory, copy the characters from the last so many characters from u into u. So then when we swap these two buffers, we keep the characters from last time without having to do any fancy, like, is it empty, is it closed, copy, paste, move, maneuver. And theoretically, it wouldn't really save very much time here because we're recutting out very little work, but it will, in that we have to do it 1,000 times, mean that these other threads start working slightly sooner and stay working slightly longer, because again, as I'm saying, like, they're not actually staying at 100% capacity because they keep... Anyway, we swap this and then we say task pool spawn. I think the question is actually, is it going to be the same? Is it going to be right? But well, I think I've got enough crash points where, like, if a value somehow gets through the wrong way, it should result in it crashing, meaning that we don't, like, 6 seconds. I don't think we save very much time, but in theory this is better, and it should have crashed if it was wrong. it is slightly faster. So this is not really worth the time to optimize. Anyway, this is more efficient. Reserve carry of blah, blah. I again don't actually know if the values are even correct, but they should be. Like I can't imagine why it would just not work. Anyway, I also still despise the fact that it's just $9.99 on everything. Like, why? I still need to parse the value to get it out. It's not like it costs. Actually, it might. What happens if I just don't? What if I just don't? Like, if this is significantly faster, I'm so annoyed because it is just a way to cheat. Because I know that the test data has just got 99s everywhere. That the statistical odds of not hitting a 99 are so low that you may as well just pretend that everything is fucking 99. Which is stupid. Anyway, did it make it any faster? Just like not storing the minimum maximum. Results, no, log. Yeah. Not really. So it's not actually any faster. So that implies that the CPU is probably just, you know, pipelining these instructions. That or I didn't save it. You know, it's not doing anything. So, so this might be just a terrible way of doing this. This is all inline always. Hash with capacity. I feel like if I drop this capacity down, maybe if I made the capacity power to power 10. So 10's about 1,000 if I remember correctly, because just like it's one of those weird numbers that lines up like 2 to the 10. So we need to be like 2 to the 13, 2 to the 13, 2 to the 14. Yeah, okay, big difference between. Does 2? Okay, so 1 shifted 14 to the 14. That is my question, is if I make these like powers of 2, that actually makes them that much more efficient to do. I can't imagine it would, but sometimes. Nope, made it slower. Which does kind of imply that it might a second slower, half second slower. It might actually be a better idea to go with maybe 2 to the 12. Or is it 2 to the 13 is like 8,000. So annoyingly, I know that you're not actually going to be the right size and you'll have to grow. You growing is dangerous. Because that will take a lot of memory. Well, not a lot of memory, a lot of time. So it's slightly slow. It's faster but slower. Like, and I suspect that that's the difference between this. So I'm going to say that you go back down to like 10,000. That's the thing. You need to be big enough to actually hold all the values. These ones don't, because there's not a guarantee that in their chunk of data they will hit every single city. But with the data being that big, most likely, I don't know. Did that make it better? Result. Yeah, within noise, so not really. Right. So one thing to do would be to make these things, these hash maps pooled as well. That's interesting. Maybe I can do that, because pooling them, one, will save a hell of a lot of time down here, because we go from needing to combine over 1,000 of them to needing to combine only like a fraction of a second, like to like 32 of them. So what we want to do is something like maybe here const static hash map. I keep forgetting. I need to put a note somewhere to new file to try. I need to swap this. So swap hash map ampersand and index map to byte vec u8 over string. Even a stir would be better than fucking, anyway. Rename to try.txt so it doesn't keep, I think it just picks whatever thing you were in, so it's trying to think it's Rust because that's what I was in. Anyway, static hash map. Cool. So this annoying, I don't think, maybe I don't know. Once cell. So std core sync. No, std sync is the sync. There's a once lock, which we could do, which like I think once lock lets you like make lazy static. So, and then we want this once lock to be a std sync read write lock, I think. And then it's going to be a vector, and we should let's just make a type up here. Type store, which is going to be like a hash set, so that we don't have to like keep running it. Store it equals like this. Maybe let's can I specify what you do? Get. So new initializers set wait. Like can I initialize you? Create a new uninitialized cell, but like how do I initialize you? Okay, I feel like maybe what we can do is we can like take advantage of the fact that again we have all these task pools, so we can just pull up a task, be like pool.spawn. Not scope spawn. And this one's just going to be like, can we maybe go down here and be like, fn start, create pool, create store, right? And it's going to be like hash pool get or init. Just, can we just call init? Init? We can just get or init. That's fine. And then like yeah, vector with capacity, and then yeah, vector.push, and then rewrite block new vector. Cool. Can we then be like, hey, can you like create rewrite pool? Is that like just a thing that we can do? Can we just pass you in? No, you have to be a future. Okay. Async. And then we need to like call like detach, because I really don't give a shit if that task runs forever. I don't think it will. I think the executor destroys it once it's done. But the idea is that we can start doing that before we spool up. Like then we can be running through this like loading and spooling up. But oh, this means this doesn't mean to be so we can then like spool this up while we wait. Right. So then when you parse, instead of your store being this, can we say like your store is hash map pool the data set on Huggy Face. Yeah, I didn't see a previous comment. Like the last things I was bringing, like the only comments I see is like someone saying they won't be here, and then someone saying hello. Like I didn't see another comment from. YouTube's like that sometimes. Like I've had ones where I'm like, I look through my analytics and it was like, oh, you had like 4 messages, and I was like, what do you mean 4 messages? Okay, so you're saying it's on Huggy Face. 1B. Interesting. one, yeah, plugin phase. Yeah, I can just download the. And data. It's been disabled for this data set. Okay. The question. Measurements. Okay. Do they have the okay, I'm assuming there's measurements and then like this thing and then out, and I'm assuming out is the answer. Okay, cool. Measurements complex UTF-8. I doubt it. Now question. I went 220. So I see the billion. The issue is that it's like for multiple zip files. So that's terrifying. Large file pointer details. Now the question is, I don't think I have 7-zip. Do I have WinRAR? No. Okay, so I guess I'm downloading 7-zip. Okay. So I'm just going to download the 3 bits of file. Hopefully. Is it downloading all 3? No, it only got one of them. He's hoping 7-zip doesn't do some kind of like annoying thing where it's like, no, these are 3 separate files. So this feels like one of those Linux situations where like Linux always has like tarballs that are split into multiple pieces. Yeah, and then we just download. We just like, yeah, don't delete that. That'd be really funny. So can we like, nope. Can I go like raw maybe? A, C. Back. All right. So we're going to say new file. It's going to be called gt.out, which stands for ground truth. I'm going to have to parse that and turn it into the format that I actually want because I think this is really ugly. Yeah. So I don't think it was supposed to be giving me 99s. I think there's something wrong with their generating script and they just never fixed it because it's like it was supposed to use Java and the Python one's just broken. Fair enough. That or I'm doing something very wrong, but like there's just 99s in the code, so like as soon as you hit a 99 it just doesn't work. So I think it's probably something wrong with the Python script or something. Anyway, let's write a little macro that's going to go through and fix that GT. So this is do well. So I'm going to like get mute. I'm gonna unwrap you. Actually, I don't think I need you mutably. Actually, so we're gonna be like get dot unwrap dot write dot unwrap dot pop dot unwrap. Yeah, hash map. And then we get to the end here, and you go, hey, you don't return anything anymore. You just run. And I just want to be like hash map pool dot get dot write dot push and install. Okay. So we're going to pop off map, hash map from the pool, return the hash map. Now, the issue is I have a suspicion that it's not going to run them to completion, which makes me worry that it's not that one thread's going to get to run and then the next thread's going to get to run. So, like, it may split the tasks, and if it splits the tasks, that's going to cause issues. Anyway, so these now return nothing. So instead of doing that, we're going to say, did I commit whatever I was fucking around with earlier? Maybe, but whatever it was, it's too small for me to give a fuck. All right, it's not like I made a big change, I don't think. Anyway, so we're going to say pool, hash map pool dot get dot unwrap dot write dot unwrap dot drain. And then okay, maybe I shouldn't have deleted the whole thing. Maybe I was just supposed to be replacing the word tasks. Okay, well, we have to wait until all the tasks are done, but anyway, so there's a hash map hashpool dot get dot unwrap dot write dot unwrap dot drain dot. Now technically, why did I put unsafe? Okay, drain, and then we say let out is block on task. All right, so we need to for task in tasks out. So we just need to say like Bevy task block on task. Cool. So all that does is we're just going to make sure that every task is finished. So, await all tasks, and this is just task. So this is like store. Like that. So that should save us a lot of time not having to thingy each time. So instead we're just going to use the same 32 maps or whatever it is. I don't know how many maps I told it to make. It made 32. I'm going to say something that's like Bevy task available parallelism. I believe get the logical CPU core count available on the current process to the current process. This is identical to STD threads available parallelism, except it returns default value of 1 if the internally error is out. Okay, cool. I would also like to know that, please. Print line. Cool. And if I run this while I go download 7-zip, oh, that's what we're making like a macro to like I like little these tests that do stuff like side effects that I'm just like, yeah, they're still fixing. All right, and it's fn clean dot out clean out file clean gt. Okay, so what we're gonna do is gonna say let file. It's not measurements, it's gt dot out. Right. So I'm gonna get that, and then this is gonna be the output file, which is gonna be gt cleaned dot out. Okay, so we have a string, and read the string. You know, read the whole thing. Okay, so what are they doing? So it's like place equals. So we're gonna replace all equals all commas with new lines. Okay. Then we might have to tweak it just a little bit to make sure that they actually the same. So we're going to say like for line in lines. It's not even for lines. It's like, so we're going to say like string dot replace. We're going to replace all curly braces with nothing, with empty strings. We're going to replace all closing braces with empty strings. Then we're going to string dot replace all. I don't think quotes the right thing. We're going to replace all equal signs with. Does that have to be a string? It does have to be a string. God damn it. With parentheses. All right. So that's going to be like that's going to be gone. That's going to be replaced. We need all backslashes. Actually, what does my results look like? We need to replace the first backslash with a min. No, we can just leave it like that. I don't like it all being. We have to replace all commas with comma spaces with we're gonna like string dot replace comma spaces. These need string comma. Oh god, what did I do? Comma space with a new line like that, and then we say wait, what do you mean must be used? You return a new string. The string equals, thank you. Can we then stdfn. Oh, it's write out string. All right, does that work? Who knows? We'll find out. Let's just download 7-zip. 7-zip, and then yeah, sure, 7-zip. Come on, over here, install. So what do we got? So the cleaned. Hey, there you go. Now I have to like make sure I get that data set. So their one's got way less. Mine's gonna get so much. What? Wait a second. Does that imply that that country? We need to go track down this country because I think it's got a comma in its name. Okay. This country. Yeah. So it's got a comma space. Why? Okay. Comma space. Okay. That looks fine. Again, this is more formatting because okay, I'm not formally competing in the competition, so I don't care about their shitty formatting rules. Washington, which implies comma space DC. We're just like looking for things that were broken. Okay. So is 7-zip done? No, 7-zip is installed. Okay, close. 7-zip. Okay. So here we go. Computer. What? No, it's downloads. I don't know if I can know what my downloads drive is. My demo spotter. I'm gonna go here. I'm gonna copy this to my C drive. I should probably delete these after because they're gonna fucking clog my C drive. Is what they're gonna do. One of these is not like the others. Okay, so we're gonna say, okay, open you. Maybe. Extracting. Where are you extracting to though? Where did you extract to? Oh, yes, it's too big for Notepad, but you didn't tell me where you put it. God damn it. Wow, very helpful, 7-zip. Very helpful. Where the fuck did you put it? Okay. Can I extract you here? No. Okay. Extract. Well, apparently you extracted to my documents. Desktop. So did they just split it into 4 separate files? Okay. Was I putting it? Yeah, fucking. No, not desktop. Why is desktop on this list twice? This PC. Why? Projects. 1 billion lines. Assets. Yes. Okay. Question: is this 1 billion lines? I doubt it because it's only 13 megabytes. So it's apparently 12 gigabytes. Never mind. The compression ratio on this thing is insane. Wait, does that mean this? Why is there 3 of them then? I don't quite understand. Do you have 1 billion lines or not? Each of them is a gigabyte. Question. 1 million text. Is 7-zip just clever enough to know that when I open... No? Oh. Okay. So 7-zip just doesn't... It won't let me open the other... Okay, it only... So I assume it's just clever enough to re-stitch them together. Okay. So we're going to rename you like to like... holes, maybe? I don't know. And then we're just going to rename you to... Oh, close. I'm going to rename you to... this. Radio, hello, please, can we run this and see what the fuck you do? I feel like it's going to solve it much quicker, but I don't actually know. Creating 32 hash maps. Yeah, it did in 4 seconds. I spawned 800 tasks. I feel like this is a much smaller file that they've given me. So, results. Right, I should modify how my thing outputs so that we can actually like directly compare. But anyway, let's go to the top of the official results and go, hey, we got like AHAA. And then mine says like negative 300, 37, and then 18. 18's wrong. No, wait, no, 18's the average and max. Interesting. Mine says that the average is Oh yeah, I haven't fucking divided by 10. Yep, cool. I forgot that I wasn't fucking around doing right things. Yeah, let's make our output the right values. Okay. So when we print the answer, when we print the answer, we need to make sure that our answer, wherever we're doing that, our answer needs to print the same as theirs. So that's a colon. Is it space? No space. Just colon min slash average slash max. The average here, measurement dot average. Where do we compute that? It's like up somewhere. We iterated through you before, right? Yeah. Yep. Okay. So what we can do is probably just like times you by 10. I think. Right? Does that work? I think so. Because if we multiply the count by 10, then we just effectively reduce the average by a multiple of 10. Sorry, I was looking at other stuff so I didn't see your messages. Smaller data will work for developing too. Also, I get with what? In one entity, I had cheat with rounding a little. Okay, measurements. Yeah. Yeah. The output is, I guess, what it counts. Well, I don't get why my output's broken. Like mine just, when it generated a billion values, the statistical odds of picking numbers that are apparently like greater than 100 or something, like 99.9 positive or negative is so high. Like it's like each city, when there's 10,000 cities, has to show up at like at least 1,000 times or something like that. Well, no, it's out 10,000 times. Each city has to turn up at least 10,000 times to get your billion lines. Means that there's only 2,000 possible numbers it can roll. So I just kept rolling high numbers, I guess. Their Python script like didn't stop it from doing that. So the result was that every single time you'd get really high numbers. Anyway, we need to, right, this will do. We're filtering our answers to actually be the correct format. So we're doing this, so we divided the average by 10, or by multiplying that by 10. Yeah. So that should mean that this actually formats correctly now, and then we just need to be like, I'm gonna be lazy, because I think it's funny. Also, yeah, you're the average, so never mind. You are the colon point, one. And then you are the this is dumb approach of, so it's min, average, max, right? Like that. Except so it's min. Let's see, min divided by 10. Ooh, divided by 10 is bad. Anyway, I'm lazy, so divided by 10 and max modulo 10. All right. I think there is a way you can get it to, because technically when it computes the modulo, it computes both. What does my results look like now? Why did it give me -8? I think I need the absolute, because if it's a negative value, it just gives the... Okay. Oh yeah, because in the modulo of a negative number. I hate that. This is gonna slow my code like right down, in that actually doesn't matter with all of this. The sheer like volume of numbers that need to be computed right out is so tiny, hence in my results. It takes 7 milliseconds. It's not exactly a large compute to convert the numbers like that. Anyway, the results. Okay, so now we need to like go like, hey, you go here, and then it's gonna like close all of these because it's really annoying. Close all, and then we're gonna open up the OG cleaned, and that's gonna go over here. Wait, what? Why can't I? Okay. So we've got the results and the GT cleaned, and then we're gonna go, hey, that looks the same to me. That looks the same to me. That looks the same to me. All right. So I guess now we'll just write a little like thing that runs at the end, and we're going to go like, hey, let's compare our results. Okay, so I really should split this into files, but fuck it. It's all going in one. And then check. So check. Check is just going to do this, and then check's going to be like, so this is my file, and then let me We don't need mute. Just let file. Actually, I did need mute because I need to read it, I think. Let mute GT and it equals options read true GT clean.out. And then we go for alright, we have to read them both the files. There's a way to be like std fs. There's like a read to file, isn't there? Read to string dot slash assets. Okay, and then same with you. I don't need this fancy stuff. Std fs. Okay, not measurements, results. Okay, result. Right, something like that. We go for I, comma me gt in file dot line. Wait, what? How did I turn back in? Okay. Alright, fuck you. I think the AI tab completed and the AI like overwrote my fucking get string piece of code. Anyway, file dot lines dot zip with gt dot lines dot enumerate, and then we go if me does not equal gt print mismatch line does not equal. Okay. So neither of those apparently need to be mutable. No, correct, because I changed to a different file format. Now check, and then we're going to do this after we've done it, because I don't think comparing them should be added to my time. Anyway, not like it matters again. This is going to take like a few milliseconds compared to everything else. Nope, that's inside. We're like storing something. Right. Oh, done.store. That's to stop the ticker. Yeah, cool. We'll paste check there then. No, we'll just wait. Oh, actually, we should do that, because we can say check should then like return bool, and we should say that pass equals true, and then when we get to here we say pass equals false, and then we get to here we say pass. Right, yep, drop that out, and then we can say cool. We can be like right line results and then it's like this, and then it's if check passed, check failed. Okay, do that and go like, hey, we'll find out in like 10 seconds if we, hey. Why did I put it on new line? Oh, because I probably have fucking right line. Yeah, you're right. Thank you. Hey, the check passed. Hey. Okay, so good to know that this entire time it has in fact been working, and it was just the data that was so scuffed. Okay, good to know. So let's go to the Git and be like, well, I don't know what I was doing. I did a bunch of stuff. Oh, we added task. Added hash call, ampersand, and the data check. Alright, so we're going to commit that and be like, hey, so how much faster was it? Look at our log. We're like, so it only takes 5 seconds. Annoyingly, this is when we swapped our data. Should probably note that. New one the line. So we saved 2 seconds by using a different data set. So I don't know how you count that one, but optimization, just don't do it. Remove the hard stuff. So I do want to try with our our hash things. See if I swap this out to being like, I want to say just for now we'll go with a vector of U8s, and we're just gonna like literally not convert back into a string. And then we can convert back into a string when we're done. But like when we parse everything, we convert to a string at some point, like store entity name, right? We unsafely convert back into a string, so we can just like not do that. Right, we can just like station to vec. Done. I do kind of want to pre-pass the data and be like, hey, like how many bytes do I need? Right, so then you do this and you do this. And so you on the other hand, you index map bastard, you actually do need to be the correct thing. So what we need to do is we need to say, hey, for key, right, we need to say like let k equal, paste this in, and then this is just k. Right. We unsafely convert it back into a string because again I actually don't care at this point whether it's valid UTF-8 because it shouldn't be invalid, and even if it is. Now, the question then becomes, well, we still pass the check. It didn't get any faster, but we're still comparing the entire key. Now, my question is, what is like the longest name? There's some pretty goddamn long names. It's also at a certain point not worth wasting the time. So, chars, how many? There's like 8, right? And then 32 calculators, 64 by 8 is 8 here. Okay. So we could take the first 8 characters. So what I need to do, I guess, is we're going to put it here just because we only care if it actually happens. So what I want to try is let all equals hash. We'll go with a hash map because then we can store like what collided map hash default new. So what we're gonna do is this is gonna be all, so we're gonna be like new, right? So what we're gonna do is we're gonna say like we're gonna say something like let key equal fucking 8 bytes. Fill copy from slice reference to k. Right, so I believe, okay, fuck you. I believe that should fill that with the first 8 bytes. I don't think it has to be the same size. Panic. God damn it. Fuck you. Okay. I don't like that I need this extra logic, but anyway, we're just checking. If key is greater than or equal to 8. Okay. Else not k key k. If k.len is greater than else yeah, what'd you get? So then we generate k, and then we're going to say tasks, I don't, all dot insert key, insert key and k dot clone, right? And then we're going to say if let other equal, and we're going to say if other equals that it does not equal k, print one hash collision between other and k, right? So basically, we're just looking at the first 8 bytes and being like, hey, what are the odds that the first 8 bytes are shared between every single town? Ooh. Wait, are these the same? Fuck you. Okay, so it appears the only collision is between this exact fucking city. Like, there's 2 cities that collide, and they have 1 letter difference. Okay. What if we instead said is greater than or equal to 9? 0, 9. And then we just said grab the next 8 digits. The answer is fuck you. Is there any? No. Okay. So that can be our hash key. I am curious if I shrink the key down to a 32-bit number, would it be even better? So we know for a fact that with this key, we would have no collisions. Which interestingly, outside the fact we'd have to keep like a copy of each name, we could then stick the name into the measurement and then just store the key and then print the name at the end. Ooh, outside. Oh, damn it. I was going to say that what we could do, actually, we could say you fill from 0 to like 7, because all it is we need to capture the 8th key. So we're going to say like U7, all right, and then we're going to say key 8 equals K9. So we just need to do that so that there's no collisions, because that's like hopefully, because otherwise I was gonna say like we need to keep it in alphabetical order. What are you doing? Okay, wait. Measurement key. Okay, so your key is the vector. Where did I fuck up the type? Where did I fuck up the type? Up here. Oh, you return a string. Yeah, no, you return a vec. You wait now. Can't imagine it's going to be any faster. Anyway, all. So now we're going to pass in key instead. Wait, yeah, that changes you again. You're going to return a U8 by 8. That's your key. Okay. So U8 by 8. And pass that in. We're going to have to modify the measurement to actually include the name. The other option is just to keep a fucking hash set of the names. Because we do need to know the station name, and it's saying, hey, like, you can't do that. So I mean, we could probably get away with that. Nah, fuck it, just store it in here. Name string. Ironic. Okay. Then we need to say like a measurement dot name. Right. And then we just need to make sure we actually store the name. Extract. Which I think ironically means that we don't even need to return this. We could actually return a U8 by 8 from here, because we know the type now. Anyway, when are we inserting this measurement there? So it's here. So we have the station name here. That's annoying. I reckon we go here and we say or insert. Right. And the trick with the or insert is that it means that we only ever call this okay, we have to pass in v. Okay, so that's going to be a measurement. Go away, please. Measurement, I guess. So there, look, toString lossy, and we get to get rid of the unsafe because, you know, toString. Fuck it, you're a cow now. Cow. static stir. I don't know why I made it a cow. Just because I felt like it, I guess. I don't think it'll actually work because the yeah, no, never mind. It needs to be converted to a string because technically it's not static always. Yeah, so we're just saying like we only convert the name. Now we are using the name here, but that's incorrect. So again, to keep it in alphabetical order, I guess I should probably check that it's still actually in alphabetical order. I guess I'll know when it fails. We're gonna say after you've done that, right, in here, it's like insert or yeah, it's insert with, because then I can run a function, right? And the trick with running a function is that I can fuck with the values, because what I'm thinking is what I can do is I need to extract the name from station. I then also need to actually modify the station's key. So I hate the let m equal. I don't like that it does like it reformats and destroys your curly braces, because I'll wrap curly braces and save it to get it reformatted to remove them. Then we're gonna say you return m, right? But then in between, because I need to get the name first. Actually, the smarter thing to do would probably be like let name equal string from UTF-8. Fuck it, unchecked. I don't care. I can keep the unsafe. Unsafe. Bytes is in name dot clone. Oh, we can just do that. Well, actually, why don't we just do that? So we can say like let e equals if station dot len is greater than or equal to 8, it's no. Okay, wait, no, so it's how do I do this in like an efficient fucking way? Okay, we're like key equals this, and then if station when is greater than or equal to 9, lovely. So that's our key now, which is the station. Right, then when we get to here, we just say station. Too big. Except I'm just gonna go back to doing this. I keep changing my mind about how I want to do things. Anyway, we're gonna do this, do this, do this, do this, do this, do this. Except it's not insert or at this point. We're just gonna say or insert. This actually should be even faster, simply because we're no longer like instantiating stuff. Name. Wait, what the fuck? Where's the U? No, that's where we're missing the fucking closing thing. Yeah. Okay, which means that when go away. Yeah. Okay. Name. Okay, entry. Except it's not. It's entry key. Thank you. Hey. Okay. Then we need to go back to our store type, wherever we fucking store. This is now a U8 by 8, which I think I should probably convert to a U64, because I suspect it'll have like an efficient like hash of U64. Anyway, measurement name. It's just string. Yes, it's empty string. Thank you. What do you look at my email? So first off, I don't think I need to do this here anymore, because yeah, key is just key, and then cannot find value key because it's called k now. We still got a bunch of errors to fix, but anyway. So key 7. Yeah, 2 key 7, and then I guess U would then equal 8. 7 equals 8. Key copy 7. 7 equals 8. Otherwise, just copy the whole length. Okay. I don't know if this is going to work, but we'll see if it's any faster. Oh, it mismatched a lot, to be honest. I don't think I'm printing the names anymore. That's fine. Yeah, I'm not. I didn't output the names. Anyway, well, where was I supposed to do that? That's like up here somewhere. Did I just like never assign the names? Maybe. Out. Measurement. So I am printing the name. I just apparently never. What do you mean? Oh. Okay. We need to when we can combine and mush them all together. Which when did I did it at like the end of parse file. Here. We need to say if entry.name is empty. I should fix it. I wonder if I made it faster or slower. Well, it appears to have passed because it didn't print out any failures. Where's my result? Test log. Check passed. Yay. We did not really make it any faster. I also still have no fucking idea where the slow spot is. I really should make some profiling tools. Anyway, so what if I increase the number of hash pools by just a little bit? I have no idea. They do seem to finish in order, so I don't actually think I need to, because I'm pretty sure it would have crashed when I pop unwrap if there wasn't enough. Anyway, so for instance, count. We're going to change your key to a U64, because something tells me that a U64 is going to be like specifically optimized for. What are you? You're also a U64. And we come down here and we say hello. Yep. And then we're going to say and then yeah, you're a U60 from Big Indian. I think Big Indian's right, because I think Big Indian is that the first byte is the most valuable byte. Big Indian, because otherwise the ordering is going to get fucked up. It's that I'm relying on the fact that the numbers order. It should have been faster for no other reason than because it should be faster than a string collision. Nope, it's the same speed, which again implies I'm optimizing shit that doesn't matter because something else is just so much faster. If that makes sense, like something else is just so much slower. Like it's got nothing to do with how quick I can parse the text. Maybe if we just give them more text now, because I'm parsing it faster. So let's give them 32. They're gonna make it faster? Probably not. Nope, didn't make it any. I don't think it made like fucking any difference, to be honest. It made it slower, if anything. All right, I need to do something. How do I profile Rust? Rust profiling. How do I do this though? Profiling. I just need a crate to tell me like how long it spends in each function. Mark your code like this. See below for resulting visualizations and more details on the extended API. Friendly warning, some profiling backends implicitly listen on network ports immediately when a host app is launched. If this is concerned, please review and enable profile development details. Okay. Windows only. No, I'm not doing a free trial. Optric Puffin. Okay. Hmm. Okay. So profiling. We're gonna go like. It'd be really funny if this all just smacked. I mean, it's gonna have to somehow slow everything down because I'm adding like more stuff that it's doing. And then you're saying puffin. Puffin. That button. Ooh. See, Rust analyzing fucking multi-thread very well because you can hear my computer just like cook itself as it turns on. And it's something about needing puffin something. Remote profiling. I don't care about profiling. Ooh, puffin viewer. Burped. But like, how do I do this without like? Okay, so apparently I need to. Hmm. Very interesting. It's a bit broken. Puffin. Apparently I have to do like this. And then this. Wait for that to actually finish first. So this is apparently like a profiler that will. So annoyingly, maybe like puffin. What do we need to do? I needed. Puffin. HTTP. It's gonna be really funny when I turn this on and find out that there's just like a massive bottleneck that I could have fixed ages ago and like called it good. But because I'm being a dumbass and doing it all like I am, it wouldn't work. All right. So again, and so we've got like a thing up here to view stuff. We're gonna say let. To be honest, it's actually at the point where I'm going to turn this off because I suspect that consuming that thread doing literally nothing but waiting is probably not helping. It's just there to print the time when it was taking minutes to do it. Okay, server header equals format. We need to fucking format anything. Let underscore Puff server. Permanent HTTP that server to unwrap. Okay. Puffin. Set scope on. I don't actually know what this does. Wait, what? What do you mean? What am I missing? Oh, because it's apparently server new. They need to update their Git. Okay. So set scope on, turn on and off profile macros, profile function, profile scope, etc. When off, these calls take only 1 to 2 nanoseconds to call 100 faster. This is false by default. Okay. Set scopes on. Okay, so then I go something like profile function. Wait, was there all functions? What does this do? Where and when can I use that? That's kind of what I want. Say, I want to be lazy and say, please profile everything. Profile, okay. Proc macro, place on a struct input block to apply on each function. Oh, damn it. Okay. Depressingly, the can I do this yet? Apparently not. So we're gonna like open a new terminal. Just gonna go like cargo run release. I'm gonna let that run, and then we're gonna go back to this other one and be like, hey, can we like? Oh, do I have to like restart? Maybe I just need to open a new terminal. Nope. That's annoying. I definitely cargo installed Puffin Viewer, so maybe I just need to restart code. Alright, we'll do that then. Save whatever that was. Save whatever that was. Cold. Excuse me. Weird. B project is, that's not what I'm working on at the moment. Okay, thank you. File. Open folder. Tube. Projects. 1 billion lines. Okay. So then we gotta go like Puffin Viewer. Nope, still doesn't like Puffin Viewer being command line. What went wrong? It did install, right? Or did it crash? Maybe it crashed because it seems to be installing something. Go away. File, new terminal. Run. How long did that take? 4.8. Okay. Oh, it didn't. Yeah, okay, it didn't work. Puffin Viewer. What do you mean? What the fuck? So can I just like not install it then? Okay. Does it not work on Windows maybe? What? Mm-hmm. I would just say on Linux, but I'm assuming that's a like modified like. First off, can we just get rid of this lock? Can we just like Puffin Viewer? I mean, that looks better. Mm-hmm. Oh, we didn't like that. Whatever that was. Nope. Maybe I try installing an older version. Yep, does not like it one bit. The 21. How do I do older versions? No. No. What do you mean? Did I spell it wrong? Probably, knowing me. Version 21? Nope. Oh, 21? Nope. Okay. If you want to specify a semi-version, oh, the 0 dot. No. Okay. Is it going to work this time? Probably not. Nope. There it goes. So apparently the answer is no, I can't use Puffin because it just doesn't work. Okay. Wait, maybe if I go back to Puffin, because like Puffin just looks nice, but is there like a there's like an actual like pre-built version 19? But like it's just the source code, so the fuck do you? Okay. But there's like no binary, so it doesn't help. Okay. God, it's getting old. Why can't they just work? Probably because I'm on Windows and nobody fucking profiles shit on Windows. Should check my chat, make sure nobody's saying anything. Okay, cool. Okay. None of these like show any kind of interesting. Wow. Look, there's a Windows zip. Okay, so how the hell do I use it? But can you explain how to use it? Apparently not. Interactive demo. Ooh. I like the sound of that. Weird, except it's like, how no. Oh, it's downloaded. So like, let's open this and be like, hello. Help, please, for the love of God, have examples. Test server, Python, public, prof, CMake, capture examples. Path tracer, Windows. One of these has got to be Rust. It did say Rust. I know it does Rust because I'm pretty sure Tracy's what Bevy uses. Yeah, it does say Rust. How the fuck do I documentation? Oh no, it's like a whole fucking PDF. Why can't I just look at that on? No. Real time. First step. Oh no. Rust? Question mark. Yes, but like, how do I actually tracing Tracy? But how? I don't like that it comes up with images when I type in Tracy Rust. But how? But how? It looks cool, but like how? Please take me back to the profiling thing. So so I'm using profiling features. So version wildcard. It's starting to get on my nerves that everything is just like, yeah, it just does it. Like, fucking explanation. It says it works with Rust and then it just doesn't say anything. Okay. Profiling with Tracy. Full clear examples. Can I please go to your Git so I can read your examples? It seems to be working though. Demo, profiling, screenshots. Screenshots. Ew. Horrendous. Okay, profiling. So is there like, do I go to crates and then like search for Tracy? Like, what the fuck? That sounds horrendous. Nope. This project contains Rust crates for producing traces for traces. Fucking right. But like, so it seems it's the tracing crate. This doesn't fucking make any sense. What? I'm very confused. Fuck it. Run the bars anyway. Nope. I didn't seem to have done anything. Tracing profile? It's the only one with a thumbnail. Ooh, something happened. Sure. Fucking video gaming everything. Okay. Now, please help. No, please help. Oh no. Okay, so my suspicion. My suspicion here is that, like, if I go back to you, see, because you have tracing with tracing and tracing with tracing. Okay. But it, like, if I, no, it's, we gave up on that. If I just like run release, like, are you gonna do something? Tracy client system? Oh, it panicked. Because we have puff and stuff that we no longer use. Oh, okay. OPI wants to connect to the internet. Sure. Can you connect, please? Oh, it worked. I mean, connect it and do anything. So, excuse me, what did you see? Pass file, and that took 4.8 seconds in the main thread. Okay, so does that mean if I like just go ham with this extension profiling function, parse buffer, extract, I don't know if that'll work now because it's like inline always, parse value, parse, get snippet, none of these things are actually called, I'm gonna fucking check as well. So every function will now tell me what it does. Oh, I probably should have, this is stopped. Have I greatly slowed it down? Because I feel like it's been longer than 5 seconds. This definitely feels like it's been longer than 5 seconds. I feel like Tracy's also crashed, so. Well, I killed it. Like, legitimately, my whole computer's fucking died. It's very dead. Can you stop? Whatever you're doing. What have I done? No? Jeez. No messages were collected. Yeah, shut the... Oh, no, now my computer's gone beep. Fucking had to kill it because it took how long? It ran out of memory is what it did. Maybe make these like 8. It's taken a really long time. And at least it spawned all the tasks this time. I think it ran out of memory last time. Is it doing something? I don't think it's actually talking to the profilers. Maybe it is though. Maybe if I don't control C it, it'll actually finish eventually. Yeah, I've run out of memory again. That would explain why it's getting so goddamn slow. Fucking what? What's on my? Oh, I bet you it's used. Well, at least that does tell me a way to make it better. Or maybe not. Maybe that's just where I'm paging shit. And say maybe what I need to do is move Tracy to my better drive. But it could just be that I've completely run out of memory. Oh, no, something's happening. My computer is waking back up. Now, my question is, will Tracy have seen that, or is it like, was it just a complete waste of time? Because why did my console disappear? What the fuck is going on? Why did my console disappear? Okay. So she kind of fucked up is what's happening. Well, let's bin that and make a new terminal. And then we're just gonna like discard. Yes. Okay. Connect. Waiting for connection. Okay. Oh, it's doing something. It's transferred 1.4 gigabyte. It's running at 4 FPS. It's doing something. Now apparently most of the time is spent sending fucking data to the thing because it should only take 4 seconds. It's using 8 gigabytes of memory. Oh no. Okay, well, now it's frozen completely, so I think I'm out of memory. Okay. The answer is I think I put something that I probably shouldn't have being traced, maybe. And it's really fucking it up. Oh, I think it's gonna crash again. Oh look, we're getting some memory freed up, so things should speed up again. As it fucking stops paging the fuck out of my NVMe. Actually, that's a good point. There's an NVMe, so it's moving to my fast hard drive. Do anything? It's fast hard drive. It's already slow. Oh god. Okay. Oh, I think Tracy crashed. Okay. So I need to like not profile something. Maybe it's the. To be honest, it's probably the inline shit. To be honest. What if I got rid of inline on you? And I reckon maybe just don't profile extract either. Like we need to profile it at some point, but like pass buffer and profile file are like the two that I actually care about. So maybe what's happening is that like I shouldn't be profiling inline shit. Like it's dumping lots of stuff in there. I think it's just done. It just, oh no. The other option is also maybe don't use all 32 task pools. So there's at least some CPU left for other shit to do something on my computer. So like maybe we should do that. That would be a smart idea, because from like looking at this, it's done. Like most of the task pools are empty, but it's still spinning. Oh no. Wait, why are you all... Is it still like processing data? Okay, we need to go to the task pool and we need to say like, hey task pool, can you fucking not? It's only something threads. Num threads is Bevy task available parallelization -2. Leave 2 threads unfucked. Thank you. Why are you taking so long to parse? My suspicion is because I bet it's when as soon as it runs out of memory. I actually wonder if maybe that would make it faster, because if we're running out of memory, but that's, I'm only running out of memory while I'm profiling, so. No, stop, before. If you get in before you run out of memory, it's fine. Close Tracy, reopen Tracy. Right. Because, like, what's happening is I'm running out of memory, and as soon as I run out of memory, everything grinds to a halt. So, what I could probably do... We could also probably spin in here somewhere, maybe. So, I wonder if that would actually make it faster. I would have to turn off all the profiling to know. But anyway. I probably should have you in connect mode. Is what I can probably do, because again, I'm running out of memory, is what's killing the speed at the moment. Which I'm wondering if that's just because Tracy's involved and it's keeping track of stuff. Too much stuff. Because it's like taking like 13 gigabytes. Yeah, okay. So let's stop you. And I mean, it shouldn't take too long to finish now that it's been stopped. But then again, Tracy's still taking 13 gigabytes. Main thread. Well, apparently the only thing that's running is the main thread. That's very confusing. 1 second. Okay. So the other things don't even come on until like 2 seconds in. So what the hell are you doing for 2 seconds? The parsing the file. Why is some of these so fast? Like this one took 8 microseconds. This one took a nanosecond. So the parsing is really fast. But whatever I'm doing before the parsing is really slow. So I need to like not spend so much fucking time between parsing. That's interesting. Well, that's a good to know that that's actually where my bottleneck is. Now, what I also do need to work out with this Tracy is, so what I'm concluding is I should probably tell it to stop, but it doesn't start doing anything until about 7 nanoseconds in. But that could also be like because it's starting up. Yeah, so everything starts up, so that's fine. Right, so sometimes it takes a really long time. So that's pass buff and then parse. So sometimes parse just takes a really long time. So we call parse buff, which I suspect is like a page line or something. I'll just show you guys what I can see. So like it takes like nanoseconds and then sometimes it takes microseconds. It's like tens of thousands of times slower, which I'm assuming is because it needs to fetch a page line. But anyway, parse buff. Where do we call parse? Because here's the thing, this is all one call of parse buff, because we call that multiple times, yeah. So this is one block that it gets parsed, and then parses. Okay, so it's spending a long time before it calls parse. But it can't be here. It's got to be here, like extract, is extract what's... Okay, don't inline always, and give me extract. I think extract might be our bottleneck. Also, can I just like be all like task push if tasks dot len is greater than 100, because what we only we put 16, yeah. So we're gonna say let's go with something like let new done equals 0. And done plus 100. We'll go like wow. Okay, it's if yeah. Then we go while task dot len greater than done plus 100. I think we need to actually clean it up. Damn it. So if the task length is greater than 100, then we want to say let new equals, I don't know, like removes okay, so it's called that old, and then we're gonna go actually you don't do anything anymore. I don't know if they get dropped is my issue, so we're gonna say don't block on them, I guess. We're just gonna say okay. So we can say like if tasks is greater than 100 for task tasks dot retain t dot is finished. Right, so the hope is that if it's greater than 100, we're going to ditch a whole bunch of them. Can we also like print line tasks in flight? I'm just curious. I mean, it has slowed it down. Hey, see, I only get to like 4? No, it's run out of memory again. Can we put the sleep the thread for like 100 microseconds? This is only a problem while it's tracing. It's st. Well, no, please stop. Please stop. It's still also always going up. It's occasionally going down. Std thread sleep duration from to like 10 milliseconds sleep. Just sleep for 10 fucking milliseconds. How's that gonna feel? I really should like start Tracy and catch whatever's happening. Okay. Wait, stop. I don't think 10 milliseconds is still a good idea. Maybe we should say while. I wonder if that'll work. I mean, not a bad idea. Because it means we keep like 100 tasks queued at all times. Which should be at least 3 tasks per thread. Which I'm wondering if will cause it to use less fucking memory. Because my concern is, oh, why did that do that? Is that it's only pulling as much memory as it is because I'm like not getting to the end. Until I get to the end it doesn't clear tasks or something, so that's why it was always like constantly stacking up like that. Well, we're definitely not gaining memory as quickly. Still gaining a lot of memory, which I think is more that like we're no longer this is capping our memory, it's more like Tracy is slowly killing it. Okay, and then we're just going to stop tracing it, please, and we're going to kill it because there is absolutely no need for that. My computer does not need to die, thank you. Okay, so now if we zoom in and bring it back on the screen so you guys can see, we zoom in. What the hell? Okay, so first off, parse buffer. So did I thought I removed the inline, so shouldn't you like not Let's give you like also like 100 milliseconds of sleep, maybe. Because again, as long as you don't get too far ahead. Cool question is how many milliseconds does it take for you to finish a task? Apparently like over 100. But is that because that's actually how long it takes, or is it because No, I think that's because Tracy's involved. What the hell's happening up here? What the hell is this? Price buffer. Okay, so it's like doing lots of little stuff. Anyway, why did that one thread get to continue, but all the others fucking died? What's the bet that that thread kept taking the work because the other ones weren't? And it's like it's just so slow that that one's finished before the other one's got a chance to even request more work. Anyway, what was I doing? So we're working out. First off, did I fuck up and not make price buffer? No, price buffer's fine. Extract. Yeah, extract profiling. Why are you like not showing up in the tree? Maybe you are. Maybe you just like, again, you're so tiny that it's like parse extract. Can I search? Maybe search. Extract. No? Oh, no, yeah, it is. So it's extract and parse. Why the hell do you spend so long not doing it? What the fuck are you doing between parsing and extracting? Okay, so we call extract. We parse value. Well, I mean, looks like, yeah, fucking hashing like a like this or something. Maybe the trick is to no, I'm thinking like it could be that in here parse value. Can we like, was it like profiling register thread function scope hashing. Now I'm assuming like this works in like I need to keep the let's see s equals. I'm assuming this is how you like do this now. Expected expression found let statement. So how does scope work then? Scope. Function. What do you fucking mean? Okay, so we're gonna like quick tracing, I guess, and we're gonna can I like discard? Yes. We're gonna like connect, and then we're gonna To be honest, it does not need to keep going until it kills my computer. Now we're only using like 2 gigabytes of RAM. Now, question. Hashing. Okay. Now, my question is, when the fuck does the hashing end? Because, again, parse takes nanoseconds. You take nanoseconds. You take nanoseconds. What happens if I put in another one? Because I'm wondering if like the nanoseconds is literally the it takes nanoseconds for it to say the word parse, or like hash or whatever I wrote in that fucking thing. It's like it says scope hashing. But is that until that drops back out of scope? Like that's my question. If I say like profiling scope updating measurement. No, stop that. You need to go to you and you'd be like, hey, discard. Sure, reconnect. And you stop. So question. Ooh, well you took a very long time, didn't you? I bet it's hashing and then update metric because it was while this is in before this dropped. So it's like extract runs. This is the length of extract. This is everything before we get to parse. Then this is everything before we get to hash. And then the hash stays in scope until it gets dropped, which is after we update the metrics. This is update metric, which then drops before. So hashing so this takes a very long time apparently. Well, I guess it would make sense because it's like multiple fucking things. All right. I don't know if this is going to be any good. Well, 0 shouldn't be valid. 1. I doubt 1's even a valid thing either, but so let key equal station 0. Come on. You can get there. You can get there. I guess you get 8. Yeah. You get all 8. And then 9. Oh, anything else. I mean, that means we do actually probably have to do 0 as its own thing. Except you become 8. You get comma anything. Something like that. And then we do need to go like 0. I guess 0 just return. Change to 0. Who fucking knows if that's going to be any faster? Probably not. Okay, first off, stop. Restart Tracy. Reconnect. Try that. How did you go? Did it get any faster? I don't fucking know. We need to like failed to resolve. Could not find span. No. Scope. I don't actually know what you fucking do is the issue. Create Tracy client ban. I do not understand. Okay. So I'm assuming it's something like, can I just like do that? So you don't like that I'm doing that because I'm what? I don't get it. Profiling. Scope, but like, how do I do this? I'm trying to work out like, key equals this. And let's do like profile, profiling scope gen key. Here's the issue. I have no fucking idea if it's any better or not. All I'm trying to do is work out where all the fucking time is spent. Is gen key with, oh, this one's just not doing anything for a very long time. So we get gen key. Wait, what? Surely it doesn't take that long to reassign the buffer. Gen key does take a long time though, apparently, because it starts from like here. Ah, which means that there's a very variable amount of time being able to reassign that variable. What happens when you just like get rid of that? Because that seems to be like a big chunk. Because gen key is like everything here to here, I guess. I'm not entirely sure. Like maybe if we did like profiling, profiling scope, reset. So that's where the question lies, I guess. Is if I disconnect it and then reconnect and I go, I don't run this and then I like stop and go to trace it. I know. Yeah. It's stopped. How do I, where's the data? Okay. Right. So we zoom in, like gen key, buffer, like that one took a really long time for some reason, like milliseconds for some reason. Weird. Okay, so there's a big gap here, but even just like reassigning this buffer is a huge amount. That or the implication is that this is such a fucking tiny amount of work that so I'm wondering if I can greatly reduce, because parse actually does something, like it's actual work that gets done. So I'm wondering if maybe, if instead of reassigning the pointer like we're doing, which is where buff. So what if I said instead of buff being reassignable to, we're just going to say like let use equals 0, and then we're going to say like don't fuck with that, and then just get like say like used. So where were we using buff? So extract, which is then used to dot dot this, right, rather than reassigning each time. And then reset buff becomes maybe make you middle. Yep, used is buff dot len minus used dot rest dot used. There you go. Used equals these two, like that. I think, I don't know, it doesn't seem right, but anyway. The question is, like, if I do that and it shrinks this gap to being not nearly as fucking orders of magnitude bigger, then it kind of implies that that like a lot of my slowdown is the fact that I was reassigning pointers like that. It doesn't really make sense to me why that would happen, because I would think that no, but just kind of just compute it so I can. Oh, look at some of these get really deep. They don't look any. Reset buffer. Like the reset buffer doesn't feel like it's any bigger or smaller relative to this. So what the fuck is it doing? I guess it's fetching memory or something. Like this one took ages. Why is it taking so long? I feel like I should probably go the other way around. Inline U and then don't inline U. No, I have to reset fucking Tracy first. How's it doing? Well, I mean, it kind of, I think made this a little bit more obviously like taking space. But the generating the key takes fucking ages compared to this. I mean, maybe the smarter thing to do would just be to say that the key is the first. I can't just say it's the first 9 though. Because it's not guaranteed to be at least 9, is it? You're only 6 fucking letters long. How do I make that faster? I think it's like that's I guess technically it's only this section here, which isn't actually that long. It is on some, but almost. But I guess it depends on which one it hits, isn't it? Really. Yeah, I don't know. Anyway, I've had enough of this for today. Thank you everyone who tuned into the stream. It's been interesting. I do plan on continuing this at some point, but it's just getting to the point where it's a little bit annoying that, like, I have no idea what's making this really slow, and the profiler is slowing it down so much that I actually don't know if it's getting better, considering the profiler takes fucking 20 minutes. Yeah, like, for it to run with the profiler, this is so slow. But anyway, yeah, I don't know when I'll do the next stream, but hopefully not too long. And thanks for tuning in.